All right. Thanks, everyone, for being here on time. How about the Name That Tune contest? Anyone know that right there in the red sleeves? Oh, wait. I got to get the microphone.
It's River by Joni Mitchell, and it was on the album Blue, which is her best album by far.
And the best thing on YouTube to me is Joni solo acoustic doing California. That's a really good one, too. But it doesn't have a water theme, so I couldn't play it. All right. Again, thanks for being here on time. Our first session this morning is about one of the key non-point source issues. I've always said NPS stood for nutrients, pathogens, and sediment. And this morning we're going to talk about the P part, the pathogens part. Innovative tools and methods to better address pathogen impairments. One of the leading causes of impairments for 303 delisted waters. It can be very challenging due to the variable nature of the pollutant. Wide range of sources and complexity with fate and transport. We're going to highlight examples this morning of successful methods that have been used to better understand and address pathogen impairments. Our first speaker is Gene Snyder from the Washington Department of Health. And each of the three speakers for this session will have 30 minutes, including the presentation and the Q&A. So I'll try to move them along to get done so we have a few minutes for question and answers, because I assume this is going to be a topic of great interest this morning. So, Gene, take it away.
Thank you. So this morning we're going to start on the West Coast. So as I was introduced, I'm Gene Snyder. I work for the Washington State Department of Health in their shellfish programs. And my presentation today is going to be over an effective program that we have been implementing in Washington State to address non-point pathogen pollution sources that are impacting both our marine and freshwater systems. Now, I'm going to step back and give you guys an overview of why clean water is so important to our marine waters in particular. And then I'm going to step through what this program is. It's on the presentation, Washington's Pollution Identification and Correction Program. To begin with, I don't know how many of you know that Washington State has a long and rich history of shellfish harvest. Pacific Northwest tribes have been harvesting shellfish for the past 12,000 years, and the commercial shellfish industry has been ongoing since the 1800s, when oysters were the primary protein source that were sent to California for the California Gold Rush. And if we fast forward to today, commercial shellfish is a $270 million industry that provides about 3,000 jobs to Washington State's economy. So in Washington, shellfish and clean water are a big deal in our marine areas. And so I'm not sure if you guys are familiar. Over here is a map of Puget Sound and the coast. And so Puget Sound is the second largest estuary in the nation behind Chesapeake Bay. And so we have 105 different areas that equate to about 300,000 acres that are available for commercial shellfish harvest. Now, I'm sure a lot of you are wondering why and how does Department of Health have a role in non-point pollution? Well, because shellfish are a food product and are regulated in the interest of public health, we have been designated the Shellfish Authority responsible for making sure that the waters that shellfish grown in are clean. And those are impacted by human sources of pathogens, toxins, etc. And so, all of these areas must meet really stringent fecal coliform standards for them to be able to be shipped to your plate if you have eaten oysters since you've been out here, or any other kind of shellfish. In addition, they have to undergo an assessment of pollution sources. And we implement national standards that give us these very strict regulations. And so because shellfish are so important and Puget Sound as a whole is so important, we have additional state regulations and programs that go above and beyond national standards. And so when shellfish harvest becomes restricted due to pollution sources or prohibited, we call this a downgrade in classification. And so when a downgrade of classification occurs, state law requires the formation of what's called a shellfish protection district. These are only mandated and required when it's a non-point pollution source. And so what are these shellfish protection districts? How are they able to do things and get things corrected on the ground? Well, shellfish protection districts are locally formed districts that include local government, tribes, communities that are impacted. It could be the shellfish industry, the agriculture industry, homeowners associations, all come together because they ultimately are responsible for mitigating those pollution sources that led to the downgrade in classification. And so how are they doing this? Through PIC, Pollution Identification and Correction Programs. So the rest of my presentation is going to be on PIC and how this tool works, and then some shining examples of successful water quality restoration in Puget Sound. So what is PIC? Pollution Identification and Correction. It's a multifaceted program aimed at finding and fixing non-point pollution sources. For today's purposes, obviously we're talking about pathogens, but this process can also be used for nutrients and sediment as well. So what do PIC programs do? Ultimately, they find and fix non-point pollution sources. They protect and improve water quality through the development and use of data, which we heard at the end of yesterday. Data is important. And through partnerships. These local governments can't implement these programs without the community support and without, our state agencies helping as well. They respond to shellfish bed closures. They attempt to reverse declining water quality trends. And ultimately, their goal is to protect public health and creating a safe environment and creating healthy communities for people to live in. So, PIC programs, I'm sure like all of your watersheds, throughout your state are very unique based on county geography, where they're located, what their primary land use is, what the primary pathogen pollution sources are, and then ultimately, we all know local politics plays a huge role in getting things found and fixed on the ground. And this includes funding and then, enforcement regulations when you need to go there as well. And so Washington, particularly Western Washington, most of you are familiar with the rainy urban Seattle. Well, we have a pretty robust commercial agriculture industry as well in Western Washington. And we have a lot of rural residential, small homes, coastal development. About 4.1 million people live in the Puget Sound area. And so that's 67% of Washington's population. And so, as the population keeps growing because people want to live in the water, all of these pollution sources compound. So I'm going to spend a little bit of time talking about the PIC process. So this is kind of the method of how we're finding and fixing and addressing pollution sources. So identification, the I in PIC. So we use a data-driven process to identify and correct pollution sources. And so counties, state agencies, local nonprofits, conservation districts will use bacteria ambient sampling, or we'll use our data we collect as part of like the shellfish program or TMDL information that's collected for bacteria to identify the areas where they're finding the worst pollution bacteria. And so that's kind of the identifying where the pollution is coming from. And this could include segmenting up creeks, walking the shoreline, and this also includes a pollution source survey, which based on counties and where they're located, what their development is, what their shorelines look like, could be very different. They could be walking up streams, they could be walking the shoreline, looking for that visual cue and that knowledge of where the potential pollution could be coming from. And so then we move into the correction part of it, the carrot and the stick. we all want voluntary compliance when it comes to non-point pollution, but there is a certain percentage of people that, the carrot doesn't work. And so the stick of enforcement has to occur. And so voluntary compliance, are the implementation of ag BMPs, septic system incentives and repairs, pet waste campaigns, garbage pickup, things like that. And then the stick is, state, notice of violations and fines and fees or local fees associated with, failing on-site septic systems. And the whole overarching thing is education and outreach. And so we've heard on and on, yesterday, without education and outreach, there's no way to move our goals forward. So you could have an awesome rest of your process, but without education and outreach and getting your community on board to get voluntary compliance and, and be a part of the process and not just the receiver of the solutions or the corrections, you're not going to get anywhere. And that's kind of the next slide I'm talking about is what makes these programs successful. Because not every county is really good at this or very successful at this. And some of the examples today I'm going to give you are successful ones, but for as many successful programs that exist in Washington State, there's probably just as many or a few more of that are not successful. And at some point there are one of these elements that is not being well flushed out or actually accomplished, which is leading to them being less successful or it taking longer to be successful and have cleaner water. And so political support, do you have the support of your commissioners, your community, your state senators and representatives? Do you have stable funding? A lot of you administer grants, and so some of, PIC programs are funded by 319 grants, and we have some local regulations that allow for fee-based per parcel fees, and so a lot of them use that for PIC programs. Standardized procedures, we have a PIC manual, which I'll talk a little bit about later, that kind of steps through how you're going to do it. So so when you go to a property or go to talk to people, it's a process, and nobody, is cherry-picked or different. People are treated differently. Effective education and outreach, enforcement capability, and then consistent follow-up. Are we making sure that when BMPs get implemented, they apply for a permit to repair their failing on-site? Does it actually get put in the ground, and is it actually working? So I'm going to step through a few examples. I have 3. I might get through 2, depending on where I'm at time-wise. I'm going to start in Yukon Harbor, which is a primarily rural residential watershed that has no big rivers or streams. It's got a few small streams. It's primarily coastal development, so there's a lot of dense development along the coastline. And so our staff were out sampling for bacteria on the shoreline drainages and walking the shoreline and found really elevated bacteria levels in these drainages coming out of pipes. And so in 2001, we prohibited shellfish harvest in this area. And so this then spurred Kitsap Public Health and the Conservation District to apply for 319 funding to address non-point pollution and put together this 3-year project. They did multiple rounds of walking the shoreline, walking the creeks, driving around the watershed. So that's the identification part of it. And they also did a bunch of ambient sampling, segmenting of the creeks. And eventually, they evaluated 322 developed shoreline parcels. This means they knocked on people's door and talked to them about things. They evaluated 98 different agricultural properties, and then ultimately they did many, over this 3-year period, education and outreach events. And so the correction part of it, they found 51 on-site septic system failures on the shoreline or on creek shorelines that were directly or indirectly discharging to our marine waters. And you can see The top picture is a drainage field that's failing. And then the bottom picture is a dye test that they did on an on-site septic system that's discharging right out into an area where you want to harvest shellfish from and food you want to eat. That's raw human sewage. And also, let's not leave out agriculture because they also implemented ag BMPs on 10 of the highest priority parcels. So I don't know how many of you guys have been to Western Washington. It rains quite a bit in the winter. And, you know, our soils get saturated pretty easily. So the fact that we had this many failing on-sites and this, you know, many ag BMPs needed is not uncommon. So what's the success? About 10 years later, we were able to reopen 935 acres of shellfish harvest in this area due to the PIC program that the county and the Conservation District implemented. Now, their job wasn't done, because they did have those holdouts of people not getting their on-sites fixed. And so they had, you know, started another PIC program a few years after this in about 2012 to try to get those last few people on board. And I just talked to the person recently who does that program, and they're back there working next year because it's an ongoing non-point pollution issue. Let's move a little further north in Puget Sound to a primarily agriculture-dominated watershed, the Samish Bay. So the Samish Bay is highly impacted by a river, a larger river in Washington that is been developed for agriculture use. And so it's low-lying, floodplain. It has really high bacteria in it. In 2007, 4,000 acres, which is one of our largest downgrades in classification, were restricted. Shellfish harvest is restricted and still is today. But it's that interim success story, right? We all know water quality and water quality improvements take years. And with agriculture, even longer potentially as your potential pollution source. And so Clean Samish Initiative, which is the group that has been working on their PIC program, they already had a robust ambient sampling program. They had started walking the creeks and the streams. You can see all of the things that they have done from 2010 to 2014. And this work has not stopped in the last 2 years. They've actually intensified their effort because they have gotten to this success down here. And since 2010, fecal coliform contamination has dropped by 84% in the river, and shellfish beds were closed for 40% fewer days in 2014 than 2010. And if you look at the graphic, that's loading in the river into the bay, and that red line is our closure trigger for the shellfish beds. And so they're getting closer and closer to that. But similar to how we're doing water quality, it takes years, and it's taking an intense effort both from our locals and from our state partners and the agriculture industry and our shellfish industry to move this ball forward. My next example is Drayton Harbor. So Drayton Harbor has every non-point pollution bacteria source you can think of. There are 2 marinas at the mouth of the harbor. There is commercial dairy agriculture in the watersheds of the 2 creeks discharging in there. There's a city and a wastewater treatment plant. And so they were down, this area was prohibited or restricted for harvest in 1995. And their PIC program has done tons of work, as you can see, primarily related to agriculture. I didn't put all of the fantastic work that the city, the wastewater treatment plant, and the marina have been doing, because it was pre them implementing this PIC project or PIC program. And so what is fantastic and successful about this is, as of December 1st, what is that, almost 25 years later, we're going to unrestrict that like little yellow polygon up there. And so it's going to be approved for both commercial and recreational harvest. So how are we funding these programs? How have we been able to develop these programs and help counties develop these programs? Through the National Estuary Program funding. In 2011, Washington State Department of Health became the pathogens lead for the EPA National Estuary Program. We were awarded $21 million grant over 6 years from 2011 to 2017 to reduce and manage pathogens, pollution in Puget Sound. And again in 2016, we were awarded $5 million of a 6-year grant to continue restoring water quality in Puget Sound. So what are these grant funds used for? Primarily for implementation of PIC programs, on-site sewage system operation and maintenance, help fund our beach program assessment, livestock management, vessel sewage, data management and reporting, and research. So the PIC funding was aimed at state program support, so our state agency, Department of Health support, PIC program development and refinement, project implementation, and sustainable local programs. And of the $21 million, $7.2 million went to individual counties and organizations to implement PIC programs. So these are some of the things that we have done with our state money. We have created a PIC manual. We created a Shellfish Protection District best practices best library. We put on workshops that now the counties have taken over running. We no longer have to, they've taken ownership over this PIC program, and now they're learning from each other and figuring out what works, what doesn't work. Ag B&P funds, OSS incentives, and then later you'll hear about some of the research tools that have been implemented to identify PIC or identify pollution sources, and one of them is sewage sniffing dogs and chemical tracers, both human and animal tracers, male-specific camouflage, and then microbial source tracking. So basically what I want you guys to take away from this is that in Washington, PIC programs have been successful, but like any other program or any other tool, it's long, it's complicated, it isn't always successful. You've got to kind of try again to address potential pollution sources. And if anybody has any questions.
Oh, yes, there are a million questions out there, I know. Who's first? Donna.
First of all, I'd like to congratulate you and everybody who's been involved with that. Those are some really great stories you just told. I would like to know about your on-site wastewater treatment. When you discovered failing systems, did you allow for alternative systems that are more, maybe have proven record of technology, or were you insistent on the routine conventional system?
So, it really depends on where they're located. So a lot of our, particularly shoreline failures, are on really small lots with really poor soils. So we do have a robust program, which I'm not in. We have a whole department in our agency that works on on-site sewage, but we do allow alternative systems. So outside of the gravity systems, we have, basically little mini wastewater treatment plants because there's nowhere to put them.
All right, anybody else? Here's one from Kentucky up here.
No, I don't see it.
So for the agriculture parcel assessments, so what exactly was done, and how did you get the participation, if it was required, of those landowners?
Yeah, so ultimately the state agency, I don't have any regulatory authority. We just fund these programs. And so locals, there are some locals that have code that if they see a violation, local health departments mostly local health departments have the ability to then go and talk to them about getting things fixed. But we use our conservation districts a lot and partner with our conservation districts, whether we're seeing actual pollution coming from ag land and assessing then what needs to be done to keep the water, keep the manure from running into our creeks and our ditches and into our marine waters. Or also, we have a regulatory tool in our Department of Ecology that then can go kind of after them to address it from an enforcement mechanism. So we really are going with voluntary compliance, talking to them, hey, we see this going on. This is a high likelihood that you are going to discharge or something is going to go on.
Other questions?
Yeah, hi, I just wondered, do you do any oyster shell or tissue testing of the oysters along with it?
So we have, but that's not primarily how we regulate it in the U.S., and so we're not required to under our standards. But there are some tools that we have used to try to figure out male-specific coliphage is one where we use tissue sampling, which mimics viruses more closely than fecal coliform. But, you know, some citizens may as well as part of, you know, our Sea Grant program and things like that. But ultimately, we only go on water quality.
I have a question for you about property rights. We have situations where we know, like, let's say you were a cranberry grower.
Yes.
And you had a pipe that comes out, and that's an intermittent discharge to a water body. So we don't really have the right in Massachusetts, as far as I know, to actually go on the person's property without permission and grab a water quality sample unless it's flowing. So when you say that you're going to be walking down people's, you know, in front of their houses along the beach walk, what are the rights? You know, because I know this is different probably for different states. What do you run into as far as property rights and being able to walk down there and take samples? So we have rights under our WAC, under our code. From a shellfish perspective, we can walk the shoreline. We have our Attorney General there's a whole regulation that explains that we have rights to walk the shoreline and identify what could be potentially impacting shellfish in the order of public health. We don't have rights, and a lot of our local jurisdictions don't have rights, or their attorneys say that it's not tight enough to be able to address that. And so a lot of them spend a lot of time working on getting property access. And it's a huge barrier in Washington as well, because our creeks and our streams, we don't have the authority and the legal, like, statute that says we can walk the shoreline like they do our marine waters. So you are not alone in struggling with that. A lot of our county jurisdictions do. But from a shellfish perspective, we can walk the shoreline. And if people ask us to leave their property, we typically do.
Paul, do you take a lot of enforcement actions?
So from state health perspective, our only enforcement action is to close shellfish beds. There's a gentleman here from Washington State Department of Ecology, Ben, who is speaking later. He can probably give you a little bit better information on how many enforcement actions that are related to Nonpoint pollution sources.
So you don't do anything like if somebody with their septic system doesn't comply over time, you can't take an enforcement action against them?
Counties do.
Okay.
Depending on their regulations.
Do you know if that happens a lot?
Depends on the county. It really depends on their code and their regulation whether they do. So I would say some fine, and then some actually do non-occupancy. So it's rare, but they also, you know, there are some jurisdictions that have used search warrants as well to get on people's properties to dye test as well.
You had mentioned stable funding as one of the indicators of or one of the things you do to help remediate. What have been sort of some of the more successful funding sources?
So a lot of our seed money for these PIC programs have been through the National Estuary Program funding to reduce pathogens and through 319 funding as well. But now we have been, as a state agency, working with counties and local jurisdictions to try to find their own kind of fee or local county-based funding. And so some of them use, we have regulations and laws that allow you to assess a per parcel fee related to stormwater. And so some of that county money will go to addressing fecal pollution. Under the Shellfish Protection District law, they can assess a per parcel fee as well to do work to improve water quality and address problems. And then we actually have an O&M, like an on-site operation and management law that allows them also to assess a per parcel fee to address on-site sewage operation and management. And some of that funds PIC programs as well. I would say that it's not used that often, all of those tools, because nobody wants a fee and people want to get reelected.
Imagine that. All right, thank you, Jean.
Thank you,
Very good, very good. All right, we're going to hear from Nicole Sandberg again from Virginia on using the TMDL approach for bacteria impairment. And let's see if I can make this happen. Close this one out. All right, here we go.
Good morning, everybody. So I'm going to start right in Virginia, a little bit about starting how we identify our waters. It's a similar theme across the nation, but in Virginia, our standards for primary contact recreation is how we list all of our waters. All of our waters are listed as primary contact recreation. We do have a secondary standard, but we don't necessarily use it. So all of our waters that are listed related to bacteria are for primary contact recreation. And it is a challenge for us because that means that all waters, from a large river to a little cattle stream where no one's actually going to be swimming in it, is still listed for primary contact recreation. And so in Virginia, we have sorry, I'm having a little, I'm having an allergy attack, so if I feel a little
Here, this
off.
Is it right here. Hold on. There you go.
So you can really hear me sniffle. So I was going to make a political comment, but I'm not going to do that right now. So in Virginia, when we list and delist waters, we base it, see, I just did it. We base it off of a 10% exceedance rate for the violation standard. So always our goal for delisting is that we're going to be at that 10%, less than 10% violation rate. So you're going to hear this in a theme throughout the presentation a little bit later when I actually show some water quality data. So in Virginia, this is from our 2014 integrated report. About the majority of our impairments are pathogens. So just as a show of hands, does anyone know if this is a theme in your state, that most of your impairments are pathogens? Okay, I hate all of you that are not raising your hand right now. It's difficult. Obviously, we have other issues in the waters of the Commonwealth of Virginia, but bacteria is a predominant theme in our programs, and so we have developed from the impairment. So when things are listed as impaired, we develop TMDLs. The state of Virginia has regulations that require us to develop TMDLs and also develop implementation plans from there. And to date, we have developed over 1,000 TMDLs throughout the Commonwealth of Virginia, and 68% of those TMDLs are related to bacteria. And then we also deal with sediment and nutrients and all the other less important things in our perspective. But it is a huge issue, and if we can't deal with trying to find some successes in our dealing with pathogens, we're going to always be found lacking as far as our program. And in Virginia, as I mentioned, we develop TMDLs, and then we develop implementation plans for those TMDLs. And I don't know if anyone remembers, but this slide was actually, I actually used this slide yesterday, but we have developed 83 implementation plans throughout Virginia addressing 426 impairments. And of those, 85% of those impairments are addressing pathogens, bacteria. And so
once we have implementation plans, we select which plans we're going to work on, and we actually do targeted projects for those implementation plans. And of those implementation plans, we've done projects on about 48 of those. So about 58% of the plans throughout Virginia have had some type of work, some targeted implementation efforts. And of those projects, so of those 48 projects, 89% of them are dealing with bacteria. We've done some with sediment and dealing with aquatic life impairment, but the majority of them are bacteria. And we do projects that are addressing both. So we have some projects that have both a pathogen impairment and aquatic life impairment, and we address those both. So if there's going to be an implementation plan or a watershed that we work in that has multiple impairments, we do try to address both. So the rest of my presentation, I'm going to talk about a specific implementation plan and a specific project within that implementation plan, but also kind of refer back to this process that Virginia has going from listing our waters to developing a TMDL and then implementing an implementation plan. So I want to talk about Carter Run. In the northern part of Virginia, and it's in the Rappahannock River, which and in the northern Piedmont area. It is a 35,000-acre watershed. Primary land uses are forest and then agriculture. So 35% of the land area is dealing with agriculture, croplands, pasture, and then the majority of it is forested. And only 2% of the land area is actually have residential rural populations in small pockets of small towns. So the Carter Run was listed in, as impaired originally in 1998, a small section, 3.6 miles, and then subsequently in 2006, an additional almost 11 miles were listed as impaired for bacteria. In 2005, we developed a TMDL for that original listing, and through bacteria source tracking, we determined that the primary sources are humans, pets, livestock, and wildlife. So nothing too shocking in that sense, but it confirmed what we've been doing. And so this was done in 2005, and we've been doing TMDLs for a very long time. But we've been doing implementation plans for since 2001, and so there wasn't a lot of shock in that sense. The TMDL specifically said that in order to meet the TMDL, in order to meet standards, we had to exclude most, if not all, livestock from streams. Anyone, is that a theme anyone has used? Right. So again, nothing shocking. I wish I had like groundbreaking news on some of the practices, and there aren't necessarily. These are substantial land-based load reductions from pasture and croplands. This is pasture management. This is the use of concentrated or not using concentrated livestock on small acreages. Livestock density, dealing with straight pipes, and failing and failed septic systems. And one of the things that is always surprising to me, but I guess it shouldn't be, is that in this area, although it's rural, it's near Washington D.C., and yet we are still having quite a few straight pipes in this area. And it's always surprising to me. Some of the most urban areas are still straight pipes that we're dealing with, as well as failing and failed septic systems. And a lot of that is due to the disparity in income. There's a lot of very, very economically disadvantaged populations here. And so dealing with straight pipes is still an issue, as well as maintaining proper septic systems, the functioning septic systems. Pet waste, we had a couple comments yesterday about pet waste, and pet waste is a big contributing factor in many of our implementation plans. And you'll hear we take a kind of a unique approach to it, because in this area, we have a lot of hunt clubs, and we have a lot of boarding facilities for pets, and so actually we have an issue with what we call confined canines, so high-density populations of dogs, and have been identified as a very significant source. And then wildlife. And in Virginia, wildlife, and as everywhere, wildlife is an issue. And in fact, in some of our implementation plans, we can't get to the standard unless we address wildlife. And the approach that Virginia takes is that we're going to address the anthropogenic sources. But we have not ever provided any funding for or practices to address wildlife. I know a gentleman from Oklahoma, I remember being in I think it's Oklahoma, meeting, he talked about feral pigs and that they did eradication for feral pigs and I might be making this up, this might be a dream, but I swear I had this conversation with him. But in Virginia, geese and other things are a huge issue, and we've had proposals like, we want to get rid of all the geese, and that's, especially when PETA is based in Norfolk, that's probably not going to go very well. So in Virginia, we've always had the stance that we're going to, if we can implement all the human sources of pollution and the livestock and that type of thing, and then if we still are not meeting standards, we can look at alternatives to addressing that. And so we developed an implementation plan, and actually Carter Run is part of 4 watersheds that we developed an implementation plan. Some Carter, Deep, and Great Run. 3 of them are right next to each other, and the 4th one, Deep Run, I never quite understood why they included it, because it's kind of a little outlier. But we developed an implementation plan in 2006, and the reason I have these 2, these are obviously the copies of the report pages, the covers, but in Virginia, we develop a technical implementation plan, and then we develop a public plan, because our technical reports can be hundreds of pages and have all this technical information, and we provide it, if we would give that at a public meeting for all of our constituents to look at and try to implement, they would just walk out the door and like, no, we're not going to do that. So we've developed more tangible, small public plans, and I'm not sure if other states do that, but we've had a lot of success in being able to communicate, because ultimately these plans, the success of these projects are dependent on the stakeholders in these watersheds in being able to do the things that are in there, and they have ownership in developing these plans. But this might be different than other states, but in Virginia, the state develops the implementation plans in a collaborative process. We do not do implementation. We don't have any plans that are just developed by a stakeholder on their own. Other than mining, we have a couple mining plans that are done through the mining reclamation user groups. So our implementation plan for the Thumb, Deep, Carter, and Great Run is a staged implementation. So when I say staged is I told you we have that 10% violation rate. That's how we can lift and delist. And so we develop our implementation plan so we can see what we need to do to get at that point. But at that point, we still haven't met the TMDL to the 2nd stage. Sometimes it's a 3rd stage, depending how complicated the project is, will be to meet the TMDL. And so, oh, Lordy, excuse me. So, sorry, I just realized I'm really, really short on time. So just real quickly, some of the general control measures that were in this implementation plan. Again, nothing real shocking. Stream exclusion, pasture management, buffers on cropland. The retention pond might look crazy. Who was ever going to advocate retention ponds in agricultural fields to deal with bacteria? But that's to meet that 2nd stage, to actually meet the TMDL. We're never advocating that we would be taking agricultural land to out of rotation or out of production. And then residential, alternative septic systems, straight dealing with failed septic systems. And then you see this confined canine units, this is actually, we developed a BMP to address these concentrated like hunt clubs and that type of thing. So the project highlights, which is what you really want to hear about, started in July of 2016, and the sunset date on this project is the end of this year. We've been installing BMP since 2007. We've funded this through 319 as well as a lot of state and other resources. Just as a funding scenario, $2.2 million has been put, that we can document, that has been put into this watershed. We know there's a lot more money. About $1 million of 319 funds, almost $800,000 of BMP funding, and about $200,000 of technical assistance funding, and then a lot of state resources, CREP. What's not in here is EQIP funding. We, as many of you may have, we can't document how much EQIP or other NRCS funding that has been put into this watershed, but we know there's been substantial EQIP funding. Just a quick part is, our Soil and Water Conservation District was our key, as well as we had a really good, they had a really good relationship with their local health department, and then the suite of the normal partners. So we have had success. As far as looking at the implementation rate of the BMPs, we have exceeded for some of the key BMPs. For stream exclusion, we've exceeded our goal substantially. We have implemented 55, almost 56 miles of stream exclusion through 54 BMPs, and that's pretty significant. And you'll notice this is a very historic area. Some land dates back to some of our forefathers of this country. Really large tracts of land, very large tracts of land, and it took a while to get them on board, but then when we did, you're talking miles of stream exclusion at one fell swoop. We did pretty well in dealing with our residential septic. We haven't met the goal. Well, actually, we have exceeded the goal for dealing with just homes treated. If you combine dealing with repairs, replacements, and alternative septic systems. We have a general pet waste program that has been in existence, but we have yet to address the confined canine units. We attempted to with some partnerships with our regional commissions, but we have not been able to actually install any of those practices. So there is over the years we've monitored water quality. There's a downward trend on the water quality pretty significantly. Looking at this violation rate, in Virginia, we assess our waters on 6-year cycles starting in 2002, or actually 2006. Prior to that, we were at 5-year cycles, and so prior to the project, we were at about a 43 to 45% violation rate as far as the waters of Carter Run, and now through 2016, we're at 16%. So there's been a significant decrease, and I'm going to stop there apparently because I only have about 5 minutes. Is that including time for questions?
5 minutes for presentation, 5 minutes.
Oh, I thought I only had 5 minutes and no one could ask questions, but so I guess I won't. I'm going to just back up. I'm going to take my 5 minutes. So as I said, the project started in 2007. So our first assessment cycle was the 2014 integrated report that included water quality monitoring since the project started. And I don't know if you can notice, but there's a significant drop in the violation rate since the project started. We've had a 65% improvement in our water quality and our violation rates. We're not at that 10% yet. We're kind of holding at the 16 to 18%. And I don't know if many of you remember from 2 seconds ago, but I said the project's going to be ending in December, and we always get questions, well, you're not at that 10%, why are you ending? And part of that decision was because of the project lead has been working on this for 10 years, and they're kind of over it, and they've also have dealt with, they've gotten all of the low-hanging fruit, the middle fruit, the top of the tree, and it's just like the seeds that haven't been planted yet is the ones that they're thinking that they haven't gotten yet. And probably at this point it's a kind of a sit and wait. They've done a lot. We've done a lot in these last couple of years, and now we just have to wait for the water quality to respond. Also, our state agricultural cost share program will still be in existence, and that district will still be doing stream exclusion and other agricultural practices. So there'll still be work going on in the watershed. We had a success story for the Carter Run written. It's a type 2 water quality improvement, and this actually was published 3 years ago. And so everything that has happened in the last couple of years wasn't reflected in this report. And we want to be able to make this a type 1. We want to have a delisting, and we're not necessarily sure what more we can do other than, again, just sit and wait for the water quality to improve. We are going to, in 2017, look to monitor a couple additional stations to see if there's other stations other than just at the outlet that are showing more water quality improvement, and we can try to maybe capture a portion of that nearly 13 miles that are listed. Just the last two slides is just the program overall. Since 85% or so of our projects are dealing with bacteria, the surprising thing is a majority, and I don't have a percentage right now, a majority of our success stories is not actually bacteria. It's actually dealing with aquatic life. And the interesting thing is a lot of our projects where we were dealing with pathogens, we weren't necessarily dealing with aquatic life. The aquatic life responded quicker than the pathogens, and so our work for the pathogens actually allowed us to get successes in aquatic life in those same areas. So we kind of got, we were working on two initiatives without even realizing it. And so I hope to go back and look at a little more association of how many of our aquatic life improvements have been directly associated or influenced by our pathogen projects. And again, we've had 18 success stories, and we've had documented improvement on about 97 of our impaired waters that are listed in our implementation plans. And again, most of these are due to bacteria. So we've had some success. Nothing shocking in those types of practices. There's just a lot of diligent work. And that is it.
All right, very good. All right, questions. I know that was an impressive number of stream miles fenced off. Fred will go first, and then I think we've got Sue back there.
So, yeah, you mentioned closing out the project, and you mentioned the base programs that are still available. Can you comment on the number of watershed projects that you've, say, closed out in the last 10 years? And I guess any comments that you have or lessons that you've learned from closing out projects that they weren't fully successful, and any changes as you kind of move forward?
Sure. Don't quote me on any of the numbers because I didn't prepare any of that, so this is just estimates from a report that I actually was writing on this last week. But we have 45 projects that we've worked on either currently or in the past. We have, I think, about 18 that we are in the process of either currently implementing or going to be doing some closeout reports. So that leaves about 30 projects. And some of those, over half of those, were actually not funded through 319, but our partner agency, the Virginia Department of Conservation and Recreation, had an initiative to do stream exclusion and agricultural practices. And so those projects closed out partly due to funding, but they've also had some successes. So that leaves about 15 or so, 10 projects that we've implemented over the years. And we closed some of those out because when I talked yesterday about BMP funding to non-BMP funding, and we always hope that BMP funding is going to be exceeding how much money you're putting on the ground to pay someone to put that BMP in or to manage the program. And once we start having that ratio where, for every dollar we spend in BMPs, we're spending $5 to provide technical assistance to put that BMP on the ground, it's not efficient, it's not effective. And so that has been one of our ways we judge whether or not a project is really making progress. Also, it's based on partnerships. So if a district is, or one of our partners is saying that they've had contact with almost every producer in the watershed 2 or 3 times, and they're showing a decrease in the number of BMPs that are being implemented over the years, probably an indication that we've saturated the watershed, and anyone else left is probably not going to happen. Also in Virginia, we had an initiative that started in 2013 and is still going on, although we're no longer taking sign-up. We're paying 100% for stream exclusion, and so no longer in Virginia is there the excuse that you can't, that they will want to participate because they don't have funding. And so now that is the case, we can have a better judgment. It's not just that they don't have funding, it's that they don't actually want to do the program. I don't know if that answered your question.
I wanted to ask you if you could talk.
Oh, just one little clarification.
Fred, you can ask
what change, I guess, are you making changes to the program as you move forward based upon what you've learned, that element of the question?
Well, it's adaptive implementation. I mean, every project that we had from the past informs how we're going to work in the future. We have really good partnerships. The districts work with each other all the time. Most of our projects are dealing with soil and water conservation districts. We have a lot of projects that are not nonprofits. And so we realize that the size of the watershed makes a big difference on our on what we do. We realize that stream exclusion is probably the primary, stream exclusion and residential septic are our primary BMPs, which is why we've had initiatives through our partner agencies to deal with just stream exclusion, funding going just to stream exclusion. And we've had projects where we knew we wanted, or we've had watershed implementation plans where we knew we wanted, actually there wasn't even an implementation plan, there was a TMDL. We knew we were going to do a project. We knew stream exclusion was one of the factors, and so we actually developed projects, not funded through 319, before the watershed plans actually started, because we knew that stream exclusion was the #1 factor. It's considered one of the top 5 BMPs, or was for Virginia, as far as efficiency for pathogen reductions.
I just wanted to ask you if you could, you've alluded a little bit to the process of how you identify your stakeholders in the projects, like who's actually out there doing the work. Is that something that you decide, or that you get stakeholder input offering ideas, or how do you do that?
So our implementation planning process is very community-oriented. We require, part of our public participation process, we require a certain level of public meetings, public involvement in the development of those implementation plans. We develop work groups based on usually a source sector, for example, agricultural work groups, residential septic, an urban work group. And we make sure that we try to have involved or invited as many stakeholders and user groups that we are aware of to those meetings. And they actually are the ones who are looking at the data, looking at the BMPs, developing recommendations, what things, and the community informs the process, because oftentimes through modeling, we may suggest, like, we think this is going on, and Farmer Joe will be in the meeting and say, well, no, you know what, you're saying that there are 10 dairies in this watershed, but, you know, this family and that family are out of business. Now there's only 4. And through our what knowledge is available to us, we didn't know about that. So in some cases, what we think are the main issues that we need to deal with are informed through the public, and then what we or through those work groups. And then what we try to do is make sure that those work groups then are engaged enough so that they're going to continue with the implementation. We're struggling with this a little bit in more recent times. In the past, there seemed to have been a better connection between going from implementation right to from planning right to implementation. But now there's such a delay because we have so many implementation plans. Often it's 2 and 3 years, so we're losing some momentum. So we're trying to develop some processes to address that.
All right, one more quick one.
How were your residential septic pump out repair and replacement programs developed and funded?
In partnership with our state and local health departments, we developed specifications. So we actually have, funded through the 319 program, but we actually have got, specifications for all those practices. We have 6 residential practices that we fund through the 319 program. We do not fund discharging systems, but we do fund repairs, replacements, and pump outs. And so we have a technical advisory committee. We have health department officials that work with us. We have a lot of changing regulations that are going on in Virginia, especially related to alternative septic systems. And so that information is always developing. We have guidance and procedures that we require. So if someone is going to take on a residential septic program, we require them to develop a program guidance that is based off a template that we've developed that's for any funded 319 funded projects as well as state funded projects that are managed by the Department of Environmental Quality. We try to have consistency as much as possible. Right now we're dealing with the fact that we do a cost share percentage. The maximum is 75%. It goes from 50 to 75% based on income, and we're finding that we're having problems dealing with the lowest of the low income. So this year we'll be re-looking at our cost share structure and address that.
All right. Thanks again, Nicole. That was great. With 100% funding for stream fencing, Kentucky may petition to rejoin Virginia. We were split off about 250 years ago. I think there may be some benefits there. Let's see. I come all the way over. Here we go. X this one out. And now we have something a little different. We have Karen Reynolds from Environmental Canine Services, who's going to tell you a little bit about a fairly unique approach to source investigation, a positive approach to finding non-point sources of human sewage pollution. Up there.
There it is. Okay, great.
Okay. Good morning, everybody. I have a fun job here, don't I? I want to talk to you today about how we use dogs to help with non-point source tracking. And this is my cohort, Remy. She's one of our sewage detection dogs. And I'll talk more about the others that we have around the country and what we do. First of all, we were founded in 2009. My husband, Scott, and I actually, we founded the company, and we are the only company that we know of in the world to use human sewage detection dogs for this sort of purpose. And what we do is we use them to find human sewage in a variety of environments. So I'll tell more about that. We work in almost every environment you can think of. To try to help source track it, we're also a rapid screening tool and help source track it so that it can be eliminated. Since 2009, we've grown a lot. We've done a lot of work around the country, and so we are so attached to our dogs. They're also our pets when they're not working with us, so we're very protective of them. And we will not fly them in the belly of an airplane places, only in the cabin. We have one dog that's small enough to fit in the cabin of an airplane. We can fly her everywhere. So we established teams across the United States to be able to drive our dogs to the different regions that need us. So we also have teams we started actually in Michigan, and my husband and I then moved to the East Coast 2 years ago, and we're stationed in Maine now because there's so much work for us out here on the East Coast with the failing infrastructure and whatnot, that now we have a Northeast team. So my husband and I do the Northeast part of the world here. And then in the Midwest, we have 2 canine handler teams stationed in Michigan. They work in the Midwest. And on the West Coast, we have 2 canine handler teams there that do the West Coast and have done actually quite a bit of work in the state of Washington, as you may have seen from the picture before with Jean. And we have completed since 2009 over 60 different projects in 13 different states. So you might ask, why use canines for this? How many of you have dogs in this room? Oh yeah, lots of dog lovers here. You know that dogs' noses are the way they experience the world, right? We're visual, so when we're out there doing non-point source tracking, we're looking for cheater pipes and, you know, failing septic systems by what it looks like on the ground. Well, the dogs are different. They're looking too sometimes because they do recognize pipes, but they're smelling. They're smelling for the sewage, and they're smelling for the sewage at levels that we can't even fathom. So they were born to sniff. Their sense of smell is so far superior to ours. A lot of you may know this. How about when your dog finds a morsel under the oven that you hadn't known, you didn't know was there or whatever, right? A little crumb in your sofa. So they're at least 100,000 times better at smelling than we are, and some experts say it could be more than that. But there's some distinct things that they have that are different from human noses that really help us with this. And one of them is that they have lower odor concentration abilities to smell and detect that. And that comes in real handy with non-point source tracking because you know that most of the time you can't smell what you're looking for. Very small quantities of sewage can cause high bacteria levels beyond the state standards. So that's where our dogs come in. They can detect at very, very low levels. They can also detect it at high levels. They just indicate the presence or absence of the pathogens that could be in the sewage, but they don't tell us what level it's at. But they can detect it at very low levels. Also, they're able to isolate scents. So if you're in an area where you've got hot spots, you already know you have hot spots, and you need to figure out, is it maybe that property or that property or that property within a range that has a failing septic system. Our dogs can actually isolate the scent. So they'll smell it in the air, and then they will track it until it gets down to its finest point where they smell it the strongest. So we can look and go, oh, okay, there's that house right there. And maybe we should check out their septic system. They also have scent discrimination properties. So we always use the beef stew analysis. So you walk into a house that's cooking beef stew and you say, beef stew's on the stove, right? A dog would walk into that house and say, oh, carrots, potatoes, beef, onions, salt, pepper, maybe a little spice here, a little red pepper or something. So they can categorize that in their brain, and we can actually tell them which of those scents we want them to pick out and to ignore the others. So that's real handy. So what we've done with our canines is to train them to detect human source pathogens that come from bacteria and ignore animal feces sources. So when our clients are prioritizing, usually they're prioritizing the human first, and so our dogs can come in and rapidly source track and screen for that. And if you know you've got bacteria present in certain hot spots and our dogs are not alerting at that spot, then we can say it's probably animal source. But this is a complementary tool, I must say. It's a complementary tool to everything else that you use in the field, including sampling. It can just cut down your time on some of these aspects. So now I'm going to do a little demo, and I'm going to ask Jennifer to help here. I'm going to pretend that this walkway here is the bank of a stream, all right? And Jennifer, if you will, bring that over here. What I've got is, Okay, so what I've got here is a gauze pad inside a Tupperware bowl that has a little bit of human sewage poured on it from a wastewater treatment plant. We love our friendly wastewater treatment plants where we get our sewage for training. And so it's just a little bit on a gauze pad. And I'm going to turn my back and have Jennifer take this down somewhere between the, in the middle, somewhere on either side, and set it like under somebody's chair. And I won't know where it is. And I'm going to show what it's like when I put Remy into training mode, into work mode, and have her find that scent just taking her down the aisleway, that very small scent that you probably won't even be able to smell. Okay, I'll turn it back. And what's going to happen is when I put her to work, she will, no peek. She will give her alert to me that she has found the sewage scent by sitting. So she'll take a sniff and she'll try to isolate it, and then she will sit, and then she'll get her reward. So that's what you'll see. Are you ready? All right. Thank you. All right, what we saw is that she started coming into the scent cone, and so she was like, oh, she was starting to say, oh, wow, I smell that. And, yeah, you love that stuff. Come on, come on. So she was coming into the scent cone, and I knew she was somewhere close because of her behavior there, and just took a minute for her to isolate that. So that's how it would be done, how we would work the banks of a river or a stream, perhaps, to help locate that one small area where maybe some septage is leaking down into the creek. All right, so here's some of the advantages of using the canines. It's cost effective. It's cost effective in different ways. One is with sampling. We can help reduce your sampling. We can't cut out the sampling. It's necessary, and it's also necessary to help confirm what our dogs are saying. But we can reduce it by being able to really quickly screen some areas that normally you would take samples, go back, have them processed at the lab, and have to go back out in the field and take some more and before you go upstream. And so what we can do is quickly have the samples screened, or the area screened by the dogs, and then we can go straight into source tracking. So right there on the spot. So if the dogs say something's there, okay, let's go. And we just go, upstream or wherever, your priority areas are, and we go and we see what the dogs say. What they do is they keep alerting in an area until they no longer smell the smell, and they stop alerting. So we can either isolate the source down to a really small area, or we can just see it right there. Often the straight pipes are like, oh, there it is, because they took us to it. So in terms of manpower, and sampling costs. We can help reduce that. Immediate results, like I said, it's there. They either indicate it's there or not. So it only takes a few seconds for them to give us an indication versus waiting 24 hours or more for lab time for results to come back, and then we can go right to source tracking. Again, they can distinguish animal from human. So if your priority is to find human source pathogens, then we can be out in the field and give you good information one way or the other. So just as important as them alerting is when they don't alert, because we can say, okay, it's not up that branch of the stream. We can, you know, focus on this branch and this branch and go straight up there rather than, you know, trying to figure out whether it's human or animal and then have to come back to the stream later after the sampling tells us. And it's a rapid source tracking tool. Like I said before, we can just go out in the field and go. And we'll often be able to do in a matter of sometimes minutes what a lab test takes 24 or 48 hours to do, or in the terms of DNA testing with it, it may take a lot longer than that. And sometimes we can do so many structures in one day, or so many stream areas, so many miles in one day with the dogs, that may often take weeks, months, even years to source track it with other methods. We have a lot of tools in our toolbox to use with these dogs. They're very flexible. We train them to work in any environment that we present them with. So I'll talk about some of those. So we can do water sample testing. We can do urban investigations, rural, surface water, and by boat, property access issues we were talking about earlier. This comes in handy. So with water sample testing, one of our popular things right now is called ship and sniff. And so we can have you, this is for like large watersheds, we can have you gather water samples from your watersheds that you're trying to narrow down and find some hot spots perhaps, or if you've got hot spots but you're trying to narrow it down further. And you can ship them to us. They don't need to be held on ice. This is because the dogs are not just smelling the bacteria in the human sewage. The smell, the gases, the other components in human sewage last much longer, even months, and the dogs can smell that. They can even smell residual scent to where, say, your sources have dried up, and we take the dogs there and the soil is dry, but they can still smell and say, yep, it was here. It's still, the sewage smells here. We can also do that sample testing on site. So we have people that gather 30, 40, 50 buckets of, we call it bucket testing of water samples from their watershed, and we'll line them up in a parking lot or a park or somewhere that's scent neutral, and we'll have our dogs check it on site. And then basically from the results of the moment, we can do some on-the-fly source tracking. So right after the results, we confer with the clients, and we say, okay, looks like we need to check this, this, and this, and we go right in the field and do it right there. We do urban settings where we check outfalls. We'll start at an outfall. Say if you know you've got a problem from a particular outfall, we'll screen that and then move right up the stormwater system, popping manhole covers, checking catch basins if the manholes are not available, and move right on up the system. We do rural areas and streams, and I like this one on the right. That's my other dog, Logan, who's been doing this for a long time. He is so happy with himself because he found a probable failing septic system. This was in the fall, and he went out there over this grassy site and just started alerting and alerting and alerting and alerting everywhere. And we're like, oh, this is lush and green here. This looks like where our septic system has been. So he was quite pleased with himself. Surface waters, we can check shorelines, streams, lakes, rivers, oceans. We go in any of those environments to search out sources. And again, by boat, we piloted the boat a couple of years ago in Michigan because we had this idea. I used to work in canine search and rescue, and one of the things I did was my dog and I searched for drowning victims. So we learned the whole method of working in a boat, working scent, where scent comes out of the water, and knowing how to, head the boat into the wind in certain directions and whatnot, and it's just amazing. So we piloted with two of our dogs, my husband Scott's dog Sable and my dog Logan in Michigan, and it worked exactly the same way. So if you've got property issues and something's accessible by boat, we're in training with our other dogs who do this too, but they just kind of naturally did it. We got them in the boat and they just did their thing, and we take them along the shoreline, and we didn't know where places were, but the boat operator knew where some hot spots were. And when we got close, the dogs would start whining and scratching in the boat and start doing their alerts. And then we'd pass by the place, and the dogs would run to the back of the boat trying to get back to the scent so we could just hone right in on it. And it did match up exactly to where the boat operator knew that the hot spots were. So pretty cool. I have a little case study I want to tell you about that's very recent. And this was in the Lake Michigan watershed in Berrien County, Michigan, and in July of this year. And I worked with my dog, Sable, my husband's dog, but he works for me too, Sable, and I also worked with our canine handler teams in the Michigan area in Lansing. And this is a project that had been a few years in the making because we've been out to Berrien County working for the Conservation Fund for several years and had actually found quite a few failing septic systems that they had tried to get taken care of, and they're working on narrowing down things in the watershed. This is a large watershed, and I'll show you a map here in a second. But what they had been narrowing it down over the years is they still had 12 streams that flow to Lake Michigan that did not meet water quality standards, and they didn't have watershed management plans yet. So they wanted us to come out and really dig in and do a lot of source tracking and see if we could get down to get those streams and get source tracking narrowed down. So there's the watershed. Very large, and it runs from the Indiana border all the way up to a town called Stevensville. So this is the area we worked. We worked this in 4 days, the entire area. We started with ship and sniffs. So they sent us 64 ship and sniffs because this was such a large area. So they took it from where the streams discharged out to Lake Michigan and then went upstream in a few places trying to get it narrowed down so that they could bring us out for a short period of time and just really concentrate that source tracking. And out of those 64 ship and sniff samples, our canines identified 22 hot spots that had human sewage markers. We did 2 canine handler teams at a time, plus Southwest Michigan Planning Commission investigator who's the one that coordinated the entire project. And we worked in both sewered and septic areas. Most of them were sewered, but some of them they didn't know if they had septics in the area or not. And the results of that to date that we have, they're still investigating a lot of it, but based on our canine responses, we found 1 direct discharge, straight pipe, actually from a home to a stream. We found an illicit connection to a stormwater line, 2 failing septic systems, and 5 lift station sewer line failure locations. We didn't know it at the time, but when it was matched up to information that they had later, those 5 lift station sewer line locations were actually corresponded to the sanitary district capacity report locations that showed inflow and infiltration problems. So they're actively working on removing that. So that was in 4 days' time that we were able to do that. Very proud of that. All right, so now I'll take some questions.
All right, that was fantastic. Thank you. Questions?
I wouldn't want your dogs to come out to Long Island with 350,000 cesspools. I'm afraid they might have a heart attack or something. They'd get so excited.
Yeah, you're right.
Yeah, I'm really afraid of that. But, you know, you said something about, let me just see where I got it here. Your, oh, yeah, so how do you change from, you know, your dogs start doing sewage, and then all of a sudden you're going to do drowning victims, and then you just let them sniff it, and then you're targeting them for this particular scent. And, and
yeah.
how come there's such a discrepancy between what a dog can smell? Some places say they can smell 100 times better than humans, and I just saw another one that said 10 million times. So, like, why are we even playing with those numbers?
Those are good questions. The question you had about the training dogs, we don't cross-train them anymore for canine search and rescue. That was in the past I did canine search and rescue. Our dogs only do the sewage detection. That's all they do with our company. Yeah. So it's just I had that past experience and knew how to train a dog to work from a boat to do the scent. Yeah. The other question about how many times more powerful the dog's noses are, that kind of thing. Well, it's hard to ask a dog. So research on canine scenting has been sparse over the years, but they're now getting more sophisticated with neurobiology and being able to understand canine olfaction better. So they have approximations based on they can do different strengths of odors and compare humans and how they can scent with this. And actually, when we do the training with our canines, we do dilution rates. So we'll take human sewage and we'll drop a few drops in a 500 milliliter sample bottle and see if they can smell it at that level. And so we get a sense. Each dog is different too. Each dog has a different number of scent cells in their nose and how they process. And some have a finer detection level, some have higher. But I will say that every single one of our canines can smell way, way below. When you look at bacteria that's in the sample, they can smell way, way below state standards, which, it's just something that it is. And so that's why at key locations where we're saying we're getting into the heart of the place here, or we think this is it, we always have our clients take samples and run them by the lab to see the bacteria counts to make sure that it's something they need to be worried about or not.
Yeah, Karen, your program obviously is built around detecting human sewage. Have you looked at or have you tried to train your dogs, or are they able to do source tracking for non-human sewage, differentiate between hogs or cows or wildlife such as geese?
That's a great question. We get that all the time. And currently we're not training our dogs to do that because the demand we have from our clients is really to find the human. If the demand develops to where we've got more demand to do that, yes, we can do that to differentiate. And we know that because we have some great sister organizations. They're out there doing conservation work that are able to identify endangered species by their scat. So we know it can be done. We just haven't had the demand to do that yet. Sure. Yeah, sure. Hey, people call us, Call us. We'll develop the method if you've got, give us the demand.
Karen, if
homeowners see you and your dog walking through their backyard, I'm sure they're wondering what the heck you're doing. So I'm curious, can you walk through the process of you're contracted by agencies, and then do they notify homeowners that this will be going on a certain date? And so I'm curious about that process and what you do when you encounter dogs that, from the homeowner's dogs, and how your dog deals with the homeowner's dogs.
Sure, great question. Yes, we always work in the field with the client or a representative of the client, and oftentimes we'll have a whole entourage with us of public works officials, or sometimes a drain commissioner from the area that we're working with. Before we go on site, we always make sure that, and we have it in our contract with our clients, that they have gained the property permission rights, or they will have somebody with us that has the permission to go on the property. Sometimes our clients will notify the residents in the areas. Sometimes we'll be out there and we'll come across something unexpected, and they'll go up and knock on the door and say, you know what, can we get in your backyard to check out that little stream piece that runs through there? So yeah, we always have that in place, or we won't go on the property. We'll find another way around it if we can, or we'll have to move upstream and see what's happening upstream.
I know we could probably go on with this for quite a while longer, but in the interest of time, we're going to have our break now, and Karen will be here for a few more minutes, or all morning, you think, or?
I'll be here as long as you want me to be.
All right. Well, thank you again. That was really good. All right. For our next session, we're going to move over a little further into the agricultural sector here. Steve Schaff and Shannon Phillips organized this session. We've got 3 presentations here. We are focusing again on ag, non-point source pollution. We're going to talk about the critical partnership between state and EPA non-point source programs and the USDA NRCS in addressing ag non-point source issues. We're going to talk a little bit about new research and emerging opportunities for dealing with some of the country's most challenging aspects of ag non-point source pollution, tile drainage, surface water runoff, effects on water quality, and the transport of nitrogen, cooperation and watershed management between urban and ag stakeholders in Kansas, and discussion of NRCS's Soil Health Initiative, which is almost a harmonic convergence when we start talking about soil health and watershed health. Our first speaker this morning is Brandon Smith from NRCS, and he will talk about the NRCS Soil Health Initiative.
Great, thanks so much. Whoa. Sensitive, huh? All right. Is that good? All right, okay. Good morning. Yeah, my name's Brandon Smith. I'm the Northeast Region Team Leader for the Soil Health Division for the USDA Natural Resources Conservation Service. And, we call it the Soil Health Initiative, but I think it's really gone beyond that phase of being an initiative, and it's more of a campaign now. And so we got to rename that pretty soon. But, what I wanted to talk to you can't hear me. Okay? Can you hear me now? All right. So what I wanted to talk to you about a bit more is building a successful conservation system to regenerate soil health and protect our water. Like when we give a lot of soil health presentations and trainings, we talk about improving soil health as a way to maximize yield, as a way to improve profits, and so on and so forth. But what we often don't talk about is how you can protect water quality, and that's really key. Many of you probably know we have a couple definitions when it comes to soil quality and soil health, and the original definition was really, well, the capacity of the soil to function. And the NRCS as an agency and a lot of other agencies use soil quality as this term for a long time. But it really didn't catch on to a lot of people. Now we call it soil health, and this has just been something that people can embrace. We have a new definition. It's called the continued capacity of the soil to function as a vital living ecosystem that sustains plants, animals, and humans. And so what this does is this definition gives something that people can relate to. They get the idea of health, and they get the idea that the soil is actually a living organism that they need to take care of. So we've done away in the agency with soil quality, and everything from here on out will be soil health, we hope. In the past 5 years or so, we've run a pretty good soil health campaign. We've had the Unlock the Secrets of the Soil campaign, and done a lot of farmer profiles, a lot of publicity, a lot of outreach related to soil health. But we've also done a lot of on-the-ground practices related to soil health. Jason Weller, the NRCS chief, he said, well, actually, it's been more than just a publicity campaign. We've made it the centerpiece of our conservation planning. And in the past, 4 years or so, NRCS and partners have put soil health practices on more than 40 million acres of working agricultural lands. And so that's just the starting point for us, and we expect to go upwards from there on. One of the cool things that happened is the agency is very committed to soil health, the concept of soil health, and they actually created a new soil health division, which I am part of. And this was a restructuring move, so we didn't add new employees to the federal government, we just moved them around. But we have a new division director, Bianca Mobius-Clune. She worked for the Cornell Soil Health Lab for quite a while. She's now our director. And then we have a national specialist along with a national team leader. And then we've split the country up into 4 regions: north, southeast, central, and west. And each of those regions have a team leader. I'm the team leader for the Northeast region, from Minnesota to Maryland to Maine. That's my coverage area. And then within each of these regions, we have soil health specialists stationed throughout the states. And these soil health specialists, we all report directly to headquarters. And so we have kind of our own mission of what we want to do relating to basic and advanced level training on soil health topics, both to NRCS staff, conservation partners, and producers. What we still continue to promote are the 4 soil health principles. Raise your hand if you're familiar with the 4 soil health principles. All right, so we got a few hands. Good. So ideally, the first one is relatively easy. So minimize disturbance, right? So right away we say, okay, cut down on tillage. Either go to a no-till system or reduced till system. Why is this important? It helps maintain soil structure, and it helps maintain a healthy, biodiverse soil organismal community. So minimize disturbance is our first key principle. The second one, maximize soil cover. We find this to be really key as well, and we use cover crop a lot, or residue management and reduced tillage to help maximize soil cover both in season and after harvest of cash crops. So keeping soil cover on the ground, on the soil during the cropping season is really important, and that's something we've been promoting, and I'll show you some slides on. This can really help with infiltration, moderating of soil temperature and water relations, and again, it fosters a beneficial soil biological community. Third, maximizing biodiversity. Again, people are really into now using multiple species cover crop mixtures. They're into doing more crop rotations with the idea that above ground diversity is helping fuel below ground diversity. And below ground diversity would be a more stable functioning environment. And then lastly, provide continuous roots year round. So the idea being, don't have anything not growing in your soil. Keep a root in there so that soil biology has something to feed on throughout the season. And not really going into this fallow system anymore. We'd really want to make sure that we're feeding the soil biology. At the center of this, of course, is proper nutrient management. A lot of this falls apart if you don't have good nutrient management. So when we define soil health, we really look at it as properties that we can manage. And traditionally, we focused on chemical management. And somewhat we focused on physical, but rarely ever have we focused on biological management. And so that's really the key area where the Soil Health Division is going right now, looking at the soil biology and how it affects overall soil health. At the center of soil health really is organic matter. We know that, but all organic matter is not created equal. So different types of organic matter do different types of functions in the soil. And then, at the heart of organic matter really is soil biota. And you can see here the number of functions that the soil biology actually controls. It's hard to think about that they control so many functions, but it's true. Aggregate formation is one of the key ones. Okay, water-stable aggregates is one of the key indicators for a healthy soil. But soil biology also control water flow, water storage. Importantly, they help decompose residues. So I don't know if any of you have seen this test where people can go into a really healthy field with healthy soil biology and they'll bury a pair of tighty-whities in the soil, and then they'll go into another field that doesn't have healthy soil biology and bury the underwear, come back in a week, and the healthy soil is pretty much, there's no underwear except for the elastic waistband because of the activity, and in the unhealthy soil, you have a pretty much just dirty pair of underwear. So it's a great visual for a lot of people to show that, you know, there are microbes in there doing a pretty good job at breaking down residues. So, but you can see all the other functions that soil biology plays, and nutrient cycling is really key as well, and that's what we're trying to look at as well. So what we see actually is if you don't have a healthy soil biological community, you start to see this decline, this spiral down in your soil health. So really, if you don't have the habitat and food source from the organic matter for your soil biology, then your soil is more prone to compaction, crusting. Surface crusting is a terrible thing. Loss of aggregate stability, contributing to that surface crusting, and then the decreased ability to cycle nutrients. And one thing to know is that aggregate stability, so the ability of those particles or aggregates to stick to each other and remain stable under rain and other water-related events, those only regenerate biologically. So it involves the soil biology actually breaking down the residues in order to create so-called glues that allow the particles to stick together. So again, this is the start of a healthy soil. And here we show the downward spiral of soil degradation. You may have seen this in building better soil for better crops, but here, number one, you start off, there's intensive tillage, insufficient residues, low diversity, no surface cover. Well, what happens? Well, your organic matter decreases because of all the tillage. You're more prone to erosion and compaction. After that, well, the aggregates start breaking down. Surface becomes compacted and the crust forms. When you get that surface crust, then infiltration decreases and erosion by wind and water increases. Then you lose more soil organic matter and the nutrients in topsoil are lost. And then finally you get more ponding, persistent wetness, but less overall available water storage, less rooting capacity, less nutrient access by plants, ultimately leading into a yield a decrease in crop yields. So what we're trying to do is create this win-win situation for regenerative soil health management systems, where this actually becomes the norm, where we get people to reduce tillage, we have more rooting, more crops in the soil, higher diversity, better surface cover, like we spoke about with the 4 principles. What we see when that happens is we'll get the aggregates to become rebuilt, soil organic carbon increases, rooting reduces compaction, and then, whoops, that happens first. Then the aggregates become rebuilt. Available water holding capacity increases, infiltration increases, erosion decreases, and we tend to get more soil organic carbon, nutrients, and topsoil built, ultimately resulting in less energy inputs and tillage needed, more water storage, better rooting. Field conditions ultimately become more resilient and consistent, and this would ultimately yield better crop yields and lower environmental impact. So that's kind of what we're shooting for as part of this initiative or campaign. And so I want to show you a few pictures, some examples. So this concept of quality no-till is coming up a lot. And, you know, no-till's been around for a while, but quality no-till is something completely different. Quality no-till, shown on the left, is a situation where there's a lot of not only decaying residue on the surface, but also living residue on the surface. So this is really helping with infiltration, percolation, and keeping the soil biological community active. Now, if you look at just conventional no-till, where all the weeds are gone, there's no residue in between the rows, you really are more prone to all this surface crusting and this really dead, barren area here where there's no biological activity. So really encouraging people to do quality no-till is at the top of our list, because you do get a lot of runoff with no-till if you don't have residue between the rows. And I think we're all recognizing that right now. Years ago, decades ago, interseeding used to be a really big thing. And, you know, farmers would just broadcast red clover between the rows, you know, in June or July. And that fell out of fashion for decades, and now it's coming back. And it's coming back with new equipment, like these interseeders shown here on the left, and different crops, like the tillage radish here, which is great at scavenging nitrogen, and other clovers and other shade-tolerant species. So using these pieces of equipment are a really good method for ensuring surface cover throughout the season. And not only that, these interseeders also allow you to do mid-season nitrogen application. So if you're using an adaptive measurement, adaptive tool for nitrogen monitoring, you can actually apply a lower level of nitrogen by doing the mid-season application, like with a pre-citrus nitrate test. Oh, okay. All right, moving on. Aerial seeding is also, just like interseeding, it used to be done in the 70s, and now it's coming back into fashion again. And it's especially helpful for a lot of these crops that are grown way up north, and the window for planting a cover crop is actually pretty tight. So here, this is tip of northern New Hampshire, and we're able to seed winter rye into the corn before he harvests it. And then once he harvests the corn, he's got a nice mat of cover crop there, which will, you know, take up about 30 to 40 pounds of residual nitrogen. So that's pretty good. High residue systems. This is probably the newest thing and what we'll see the most of in the future right now. You may be familiar up here with the roller crimper that was used in organic systems. In this type of system, you grew a high residue, high biomass crop, and then you rolled it down with this crimper. And by putting all that residue on the soil surface, you tended to control your weeds without herbicides. So it was very effective for organic producers. But there are a lot of tricks in order to making sure that that type of system works well. And conventional growers didn't really adopt that much. But what conventional growers are doing now, those growers that are interested in soil health management, they're adopting these systems, but using them with a little bit of herbicide, so half rates of herbicide. So they're doing things like here, planting green. This is a cover crop that was aerial seeded. He's got a no-till planter. He hasn't killed the cover crop, but he's planting corn right into the cover crop, and it grows, leaving the cover crop standing, and the corn emerges, and it grows really well in that type of system. So a lot of folks are doing that. And the newest technology here, this is a company called Dawn Biologic, and they're out of Illinois. Whoops. And basically they modified this roller crimper to individual planter units so that you can actually just drive right through, open up your row, plant your corn, crimp at the same time, and be done. And these individual units, they follow the contour of the land a bit better, and I think this is going to be a really successful system that you see a lot more of. They know that they don't have to get an entire kill of the cover crop. They still can use a little herbicide to knock it back, but it's nowhere near the full rate that they were using before. High residue systems also apply to vegetable producers. We have a lot of folks now that are doing sweet corn in high residue systems, and transplants like tomatoes and other cucurbits. And one of the biggest win-win situations we have right now is pumpkins, growing pumpkins in this high residue system, because the growers love it because it's value added. They don't have to really wash their pumpkins at the end of the season. They're clean. They're not all covered with mud. So it's a very good system. And then the last system is manure management. This is something we've been promoting and working on quite a bit right now. And this is the idea of using reduced disturbance injectors and a drag line. So here we have our drag line for the manure injector, and here's the reduced disturbance injector right here. Basically, instead of driving a giant tanker over your field, you can just pump the manure into this unit and inject it into the soil. And so it reduces compaction, number one, and it gets it right into the soil rather than letting it sit on top of the surface. Because we see in a lot of our demonstrations that even compacted sod, there's quite a lot of runoff from compacted sod, and especially if you're putting liquid manure on compacted sod, it's going to run off. So the more we can get it into the sod, the better. And the other alternative here is shown from Michigan State is if you actually have this type of airway incorporation, you can actually dump cover crop seed in your liquid manure spreader with an agitator, and you can do the cover crop seeding and fall manure spreading at the same time. You tend to get a very good stand established, and that crop is just utilizing that nitrogen very well instead of just letting it sit there on the soil surface. So 3 more slides for you. I just want to tell you what the Soil Health Division is working on right now. One is developing a soil health assessment. There's a couple out there. There's the Cornell one. There's one called the Haney test. We're working with all sorts of partners around the country to come up with the best available soil health assessment. And we want to make this be standard testing for the public. So we want, in addition to regular nutrient testing and organic matter. Some of the indicators we're looking at, we call it water partitioning or macro aggregate stability. That is a very key one that we're looking at, easy one to measure. Soil metabolic activity or respiration. How active is your soil? Bioavailable carbon. We talk about that as the food source for soil microbes. So how much bioavailable carbon do you have in your soil to keep your microbes happy? Bioavailable nitrogen, that organic form of nitrogen that's able to be mineralized, and the activity of the biological organisms that are going to mineralize that nitrogen from organic matter. So we can measure that as well, probably be measured as soil protein. And then microbial community structure and diversity. So now, thanks to advanced tools, we can actually take profiles of the whole soil biological community, and we can group them into fungi, bacteria, actinomyces, et cetera. We can also tell a total biomass of all these different groups of biological organisms. So it's very cool. We hope to have this standardized test ready to go in about a year or so. We're also working on soil health planning, and really we're trying, there's CNMPs and NMPs, and we want to have a soil health management plan as well. And so this is something that we really want to integrate into the heart of conservation planning. So we've done a couple pilot soil health management plans, and we found that they really help producers understand not only the status of the soil health, but all these different alternatives that they need to take in order to improve their soil health. So we've developed the pilot plans. Now we're in the evaluation and adjustment stage, and we hope to have those ready around the same time that we have this National Soil Health Assessment ready. And then lastly, one of the newer things is this SHIELD network, strengthening the science of soil health through a new NRCS SHIELD network. This is a gigantic project that we're doing all across the U.S., and SHIELD stands for Soil Health Inventory and Evaluation for Land Use Decisions, which I didn't choose the acronym. But as part of this, it's a group of people working together. We're going to decide on these indicators that are going to be used, and all these indicators need different interpretations for different regions. You know, soil organic matter measurement in Texas is just not the same as it is in New Hampshire. So we need to come up with all these interpretations for these methods. Then we'll build an actual database for these soil health indicators, and then we're going to monitor soil health on benchmark soils throughout the U.S. and assess the management impacts. So this is going to be a relatively large project. And then finally, we're going to build these decision tools to integrate soil health status into everything that the NRCS does so that our field staff can make choices on how to plan a practice based on soil health status. And so with that, I'll take any questions about time.
Wow, yes, there is time. That was excellent. A lot has happened in the last 2 years since we had an update on the soil health program. The Haney test, could you spell Haney, first of all, before we take questions out
Sure,
here?
H-A-N-E-Y.
H-A-N-E-Y test.
So in the Midwest, we see more and more farmers going to systems that have cover crops and then integrating livestock into that. How does that affect your soil health?
Yeah, we think that that's a great thing to do for soil health. That falls under that improving diversity soil health principle. And, you know, manure has special qualities on its own, you know, especially in systems that haven't seen manure. And so if you can get a multi-species cover crop that's grazed by livestock and get that manure on the land, I mean, that really does help improve soil health for sure.
I have a question about your soil health management plans.
Yeah.
These would be plans developed for individual producers over a period of time?
Yes.
And would they be involved with the plans? Are they non-regulatory? In other words, not related to their conservation compliance plan that they might have?
Correct, yes. So they're non-regulatory. They would be involved in the plans because a lot of this will be discussions about how they need to change what they're doing now and come up with new alternatives to improve soil health. Because generally, if you keep doing the same thing, you know, you're not going to be managing for soil health. So, yeah, but it's non-regulatory.
Yes, sir. You know, one of the, for climate change, you know, I saw one brief mention on one of the slides regarding, you know, atmospheric composition. And given that soil health is a huge opportunity for mitigation, is NRCS pushing that through the soil health initiatives, and what kind of traction is that gaining among the producers that you work with?
Yeah, absolutely. So the Secretary Vilsack put out his greenhouse gas building blocks, and soil health was actually one of the largest building blocks with the potential to sequester between 4 and 18 megamillion tons per year of carbon. And so we find that that integrates really well with what we're doing with soil health. And yeah, I mean, it's just one more thing that we can say that's positive about soil health. That's a good question. I mean, we always talk about yield first and economics to farmers when we talk about soil health, and possibly, you know, improving carbon in the soil is something that will happen along the way, but it's not something that we necessarily pitch to most people right off the bat.
Yes, sir. Back here, Barry.
How long does it take before you start seeing the benefits of soil health as far as the timing?
Yeah, that's a great question. Well, in terms of some properties like aggregate stability, you can see new aggregates being rebuilt within a year. But then when you talk about other structural properties and changes in the biological community, really you start to see those, you know, around the 3 to 4 year range. And so when we've been doing soil health testing, we'll get our baseline test, we'll test 3 years later, and then 6-year follow-up.
Yes, has NRCS done any evaluation of the long-term effects of application of biosolids, wastewater treatment plant residuals on soil health?
Not that I'm aware of.
That'll kick off the biology.
Question about the equipment you use to inject the manure into the soil. Is that readily available? Is it relatively affordable? And how many people are deploying that? Thanks.
Yeah, and that varies across the country, of course, but fortunately, NRCS has a scenario in 590 for manure injection, which helps defray the cost of the equipment. So that's one good thing. There are different models that range in price, for sure, but in the Northeast, like especially in Vermont, where there's a lot of grassland and a lot of liquid manure, they're relatively common, and they're becoming more common in New Hampshire, but I can't speak to a lot of other areas.
All right, one last one from Donna.
On a very small scale, in the past few years, we bought a small composter in my backyard, and we're teaching our grandkids to compost their 3 meals a day food scraps, in addition to all the action heroes that they know. But we noticed that other children are now interested in coming to our house and saying, oh, you know, we want to understand this process. And I'm wondering, what do you do to educate the young kids about soil health? Because we transformed our whole backyard. The difference in using compost is just dramatic. It's so unbelievable. Even we don't add anything to our grass. We don't do anything. Everything is already done.
Yeah, it's a fantastic question, and we have been very proactive in that. I mean, at the youngest age, we have coloring books related to soil health, and then we have I don't know what sort of age group you want to call it, but we have varying age groups of material for varying age groups up to high school related to soil health. And then the biggest thing that we're doing now is we're actually working with community colleges that have an ag focus, and we're trying to give more talks to the community colleges and excite those type of people that are attending and maybe not sure what to do, whether they're going to be an ag service provider or what, and getting them excited about soil health and maybe working in soil health systems.
I think for the high school students, the whitey-tidy experiment would probably be the absolute best thing ever. Thank you, Brandon. That was very good. All right, now we have another topic of great interest to those of you from the Midwest. Jane Frankenberger from Purdue is going to talk to us about nitrate and tile drains. And let me get things situated here. All right. And there's your remote, right? And you've got a
Okay, thank you. And I'm so pleased to be here to talk about ways to reduce nitrogen loads. I'm from Purdue University in Indiana, and I have a long list of co-authors there, and the take-home message is that what I'm going to talk about is a consensus of most of researchers at land-grant universities and USDA ARS across the Midwest. So this is not the cutting-edge research. This is what we know to be true. There's one little point during it when it represents my opinion, and I'll tell you when that is. So when we're talking about nutrient management, nitrate management in the Midwest, we have to talk about tile drains. It's been known for years, for decades, that tile drains are the major source of nitrate loss to streams. Nothing new there. I will add that it's more recently known how much tile drains are also a pathway for phosphorus through tiles. This has really come up in the Lake Erie Basin, and so represents a lot of new challenges. I am going to talk about nitrates specifically today. Some of the practices work with phosphorus, but very unfortunately some do not, and we can't assume that. I'll mention a few times when it does or does not work for phosphorus. Phosphorus is actually going to be a bigger challenge. For those of you who aren't from the Midwest, not like my Indiana colleagues and others, tile drainage is a large plumbing system with perforated tubing installed 3 to 4 feet below the surface throughout our poorly drained land. It's not exclusively in the Midwest, but we are the heart of it. There's no census that tells us exactly where it is, so this is an estimate based on soil types and crop production, and it's so the one that's commonly used. I will point out that you can sort of see a correlation with the sparrow estimates, which I'm sure you're familiar with, of where nitrogen comes from for the Mississippi River Basin. So this isn't the only proof that there's a link there, but it certainly is a good visualization. I also want to talk, and somebody just mentioned climate change. One of the things we're starting to ask is, how is it going to change in the future? And this is maybe a familiar figure to many of you from the National Climate Assessment, and shows that more of our precipitation is falling in very heavy events, and especially in the Northeast where we are here and the Midwest. And so although farmers, it's been shown that they're very resistant to the idea of human-caused climate change, almost all of them do recognize that there's more heavy precipitation, and they need to be thinking about being prepared for that. So I'll just ask a question for thought here. How do you think farmers respond to the fact that they know we have more heavy precipitation events? You may realize they call up their contractors, or many of them are actually purchasing their own drainage plows. These are something like $500,000 equipment, or there's some that are pull behind, and there's a great deal of tile drainage that's being installed probably as we speak in the Midwest. So this is not going down in any way, it's going up. So that's a little background for a publication that we put together, and you may have seen it at the registration table. And for those of you for whom it's relevant, I'd encourage you to pick up a copy. But that's where we, put together these thoughts. And so I'm going to run through some of them. We were kind of joking, 10 ways. When we came up with that idea, it just seemed a way to show to people that it's finite. There aren't, 50 ways to reduce nitrate loads, but it may have suggested to you sort of a clickbait kind of thing, right? And so I just looked up on the internet as I was sitting there, like there's 10 ways to make more money, 10 ways to catch a liar, 10 ways to look younger, and things like number 6 was shocking. But we don't actually have a shocker, but why wouldn't we have 10 ways? So we can put them in list form. This is the list. But that's a little dry, especially for a presentation. So one of the ways that we group them is by where in the landscape they work. So the first 3 work in the cropping system. Well, I'll just go on. The second 3 work in the drainage system, right? So it's not the crops, it's those drain tiles and how we manage them. And then there are 4 that work at the edge of field or downstream. So if we haven't managed to reduce nitrate along the way, these are, sort of the last chance ways to reduce nitrogen loads. Now here's where I added a couple slides after the presentations yesterday, which got me thinking. I do want to say these are the 10 ways that work. They are not necessarily the ways that we can show to be profitable or that farmers will adopt even with the right kind of outreach. The problem, and I hope everybody understands this, is we're dealing with dissolved nutrients. The remaining problems we have are nitrogen in the form of nitrate and phosphorus that's dissolved. And dealing with these are, for the most part, not going to be financially beneficial for farmers. I can go out and talk till I'm blue in the face. You can too. The partners that you work with, we write we write publications, et cetera. But it doesn't mean that farmers are going to adopt. And I think we need to think back in the model that we've used so long, so successful, in fact, since the 1930s, that when we were trying to control erosion and nutrients attached to erosion, there's a benefit, there's an on-site benefit. So farmers, at least the ones who own their land, which of course is it's the minority of farm land now that's farmed by the owner, but at least on that land there is a clear on-site benefit, like the soil health. So this is where I'm speaking for myself. I just encourage you, as you're decision makers and thinking how to make this work, we may need to think about new models. So do we need to give higher payments? That some share of the cost that works if you have an on-site benefit is less likely to work here. Are there opportunities for social pressure? My understanding is that's the thinking behind watershed groups. Could you do something else with water quality trading? A lot of people think there must be a market-based solution. Do we need to think about some kind of conservation compliance? tied to the subsidies, which right now are especially crop insurance. And if you don't know, conservation compliance only applies to the highly erodible land or where there's a wetland, swamp buster. The rest of it, there's no conservation compliance, or people are even starting to think about regulations. So that, I want to say, is my own. But it just gets us thinking, these are very challenging water quality practices, and you, many of whom are managers, as Russ had us think about, looking at the data, how can we actually bring about change? The other thing that our book really emphasizes, again, is not just what the practices are, but how they work. And so I'm going to emphasize that in this talk as well. So we need to look at the nitrogen cycle. The first way is that we can reduce the nitrogen source. And you may not be able to see it from here, but you can read it in the book. So we've got the fertilizer or manure application, but it might be the nitrification. People are looking at nitrification inhibitors, for example, ways to reduce the source. The way we'd like things to work the most is to increase the plant uptake, because that's where farmers do benefit. That's where the profit is, if we can get the nutrients to where they're supposed to be, which is into plants. Increasing denitrification is another possibility, and a lot of our practices are focused on increasing denitrification, but that's not a profit to the farmer, right? It means we somehow missed getting it into the plants in the field, and then at the edge of the field, we try to bring about denitrification, but that was nitrogen that was originally fixed out of the atmosphere, and now it's going to go back up to the atmosphere. Obviously not a profit there. And then the fourth way, and which is so important, is that we also need to think about reducing the amount of drainage or flow entering the stream. So there's the four big picture practices. And again, in the publication, there is this overview on page 4, which kind of sets out, where you can put practices in and then how they work. And I would have used this for the basis of the presentation, I think, except it's too small to read, so we'll blow things up. So now I am going to go one by one through the practices. It'll be fairly quick, but just a quick overview. So one of the ones where the agronomists at least think there is some potential for actually financially beneficial movement is in improving nitrogen management. I'm sure you've heard of the 4 R's, applying fertilizer at the right source, the right rate, the right time, and in the right place. With nitrogen in particular, it's rate that's important and time of application. With phosphorus, what has been shown lately to be particularly important is placement. We need to get the phosphorus into the soil, not on the soil. But that change does not make much difference with nitrogen because it's so soluble. It's going to move wherever the water is. It doesn't matter if you put it on it, in it, it's going to go right to the tile. The way it reduces nitrogen loss in drainage is obviously the first, reducing the nitrogen source. And to the extent where our timing can get it right to the plant when it needs it, it may increase plant uptake. So that's what I'm going to do with all the practices, just sort of help you think about how they work as well as what they are. The second one is cover crops, and who can dispute those, especially as that great presentation before. This has so many benefits. So you know what it is. This has extremely high reductions in load. We did a review of the literature and saw load reductions from 13 to 94%. Cover crops over the winter are taking out the nitrogen when the nitrogen is lost, which is in the winter. And so it works by increasing plant uptake. That's the main one, is increasing plants at the right time. It can reduce the amount of drainage to a certain extent. And then I'm going to point it out here. I won't add to the others. But this presentation is focused on nitrate reduction, right? These are the practices that work to actually take out the nitrate. But practices like cover crops have so many other benefits, soil health being the main one, but increasing biodiversity, I guess that's part of it too. So that's just not my focus here, but with some of these have lots of co-benefits. Other ones do not. Along the same lines is changes to our cropping system. And the basic reason we lose so much nitrate is that we don't have a crop growing during the winter. So cover crops are, you can still have a corn or soybean and then put cover crops in, but a lot of people are thinking, how can we get more perennials into the rotation? We used to have perennials. It wasn't that far back. There's a lot of research showing how the move from alfalfa and hay to soybeans being almost the exclusive second crop is one of the reasons why we have so much nutrient loss now. So it's another way to get crops growing during the winter when we so badly need them. The load reductions are outstanding. This is from a meta-analysis showing that in the corn and soybean systems, nitrate loads are typically 30 to 40 kilograms per hectare, whereas in the alfalfa or grass system, it's maybe 3 or 4. It's an order of magnitude less. So huge differences. Obviously, it works by increasing plant uptake and reducing the amount of drainage or flow. This is something I hope we'll all be thinking about. You know, there was a promise that bioenergy crops may bring that about. Could we make switchgrass or miscanthus even profitable in the Midwest? And people I think, are less hopeful now than they were, at least on our prime farmland, but maybe there are places where it can work. But we certainly need to think about ways to get perennials into the system. Drainage, so those are the cropping system, and that's obviously the first place we look. But if that's the only place, we're not going to bring about reductions in nitrate. So we can look at drainage water management, which is putting adjustable structures in to manage the level of the outlet, and it reduces nitrate loss primarily by reducing the amount of drainage or flow entering the stream. And I can talk at length about that practice, but I will not today. Another practice that a few people are looking at is, could we change the drainage system in new systems and have it less intense? And that means either having it shallower, so the tile drains, instead of being at 3 to 4 feet, are more like 2 to 3 feet, and that will actually reduce the amount of flow. And this graph here shows that under shallow drainage, which is the light blue bars, there's significantly less nitrate loss than with conventional depth. That was a depth, which is in the turquoise. So it also works by reducing the amount of drainage. This is a very tough sell, and there's almost no practices that have gone in, because why is a farmer going to do this, right? There's clearly no profitability to having a little bit less drainage, and you'd have to put them either closer together or something. But anyway, it could be done. So this is a list of practices that work. Recycling drainage water is one that, getting my notes out here, could we actually, this is like the most complex and the biggest investment, could we actually catch the tile drainage loaded with nitrate and phosphorus and store it in a pond and recycle it back on the cropland? And so here's what one of our figures looks like for this. Now, I just want to mention, so we have to, obviously it's an expensive practice because we need ponds. One of the speakers, I think from Virginia this morning, said, who's ever going to implement retention ponds on agricultural land? So that got me thinking, yes, who indeed? And that is what I would have thought a few years ago. But I think our options are so limited, particularly with phosphorus. That's where I want to circle back to phosphorus. How to solve the eutrophication in Lake Erie. It's so tragic, and there's so few practices. We don't have an equivalent of denitrification for phosphorus. So how are we going to capture that phosphorus? So that's gotten many of us thinking, okay, how could we make this possibly work with a number of different funding sources? And that's one of the fundamental practices of a large project that I lead, which has a longer name than this, but this is the short name, which also has the URL in it. So if anybody wants to find more information, you can go to this site, or I'd be very happy to talk to this. We're really saying, are there ways that we could make this happen? And this would obviously reduce the amount of nitrate loss by reducing the amount of drainage or flow entering the stream. And to the extent that the irrigation, so these practices wouldn't just be a retention pond, but would actually then irrigate it back onto fields. So there is crop benefit. Probably not enough to justify the cost at this point, but with climate change, it would be moving towards more profitable, right? As we get more precipitation in the spring and less in the summer, is at least what it's expected in the Midwest. So at least we're trying to develop the systems here. So if people have ideas and places we can look at, I'd really love to talk about this one. Okay, we're only on number 6, but these are fast. Wood chip bioreactors, you may have encountered. It's a wood chip filled trench where we promote denitrification. So this is clearly a practice that has no financial benefit to the farmers, yet quite a number have gone in. There's been good financial incentives and very active outreach through all kinds of organizations to get these placed. It works completely through denitrification. The carbon in the wood chips allows the microbes to go to work and has excellent potential to reduce the nitrate coming out of tile drains. Some studies have looked at how many trees would be needed to treat all the nitrate in Iowa, and I believe it's more trees than they have. So it's not ready to work instantly, but in some places it will certainly work. Wetlands, I think you all know about wetlands, a wonderful practice with so many benefits, and they're great because they work in so many ways. They increase plant uptake of nutrients, they reduce the outflow, and they increase denitrification. And they have many other benefits that I'm not showing here, but I think you all know the wildlife and many other benefits of wetlands. So these can sometimes get implemented with all those other reasons. Some people across the Midwest are looking at how we change the ditches, because once the water comes out of the tile drain, it goes into a ditch, and then it goes straight to the stream. Is there a way to do some retention there, some treatment? And so one of the methods is to install what's called a two-stage channel, which is similar to stream restoration efforts. It gives a little floodplain within the channel, and that has all kinds of benefits by increasing plant uptake, reducing the drainage, and increasing denitrification. So that's an exciting method that we're working on. And the final practice is a very complicated one. This is hard to understand, but it's called saturated buffers. And what people are doing is looking at all the buffers that we have. And this is due to nationwide programs by NRCS and others starting in the 1990s. There's continuous CRP available. The effort was to get all our streams and ditches buffered. The problem is that in our tile drains land, the tile runs 3 feet or 4 feet below the buffer, and there's no benefit whatsoever towards denitrification or towards treating the nitrate. So the buffers may have other benefits, but they haven't reduced the nitrate. So the idea with a saturated buffer is you install a control structure and distribution lines. What you're trying to do is take the water back out of the tile lines. It's been gathered there to get it out of the field, and then it goes back out into the buffers. And it can work through all the methods that a wetland works, especially denitrification. So if the soil has enough carbon in it and plants can uptake it, that it can do very good treatment of nitrate. It's been tried particularly in Iowa, and it works very well where the conditions are right. But the conditions require a slope down to the stream, and in Indiana and other places, we tend to not have a slope. In fact, the buffers are a little higher, so we have other challenges. All right, so that's 10 practices. A quick trip through 10 practices. People are still trying to come up with different ways to make these more palatable, work in different ways. Somebody yesterday mentioned oxbow restoration. I think that could fall under the wetland kind of category because it's another way to increase retention after it's come out of the field. But it's a specific place where there might be more opportunities. We're left with the 4 methods that we have. You can increase denitrification, you can increase plant uptake, but that's all we have. So this is a fairly exclusive list. At least these concepts are really the ones that are what we have to reduce our nitrate loads. None of them great, none of them perfect. Sadly, I wish I had better news. The problem at the core is that the annual crops like corn and soybeans are leaky systems. So sometimes people say, are you blaming the farmers? No, we're blaming the corn and soybean system. And to reduce the nitrate loads, we're going to have to make some hard choices. So at least the Illinois nutrient reduction strategies, all the Midwestern states have these, is saying that no one practice will be suitable on every acre, but every acre needs at least one practice. And I love that message. How that's going to come to pass is still unclear, but that's what we're trying to say, so that there's a variety of practices. They work in a variety of ways. They have different costs and they have different co-benefits, agricultural or environmental methods. But there are at least practices. And if you would like your copy of this of the information in this presentation. There's about 100 that were shipped here, and otherwise you can get them. It's a free download, or it's available. I just looked it up. It's $4 plus shipping. So get them here. Thanks.
All right. Thank you, Jane. I was a little shocked by number 6, actually. Questions? A lot of very interesting stuff here.
Thanks. Really great presentation. A lot of these are, like number 6, pretty obvious that's going to put phosphorus and nitrogen back on the field along with the water. Seems like a good climate change, intensity of precipitation, a mitigating factor. But a number of them really would soak up nitrogen or phosphorus with the potential to reapply, like the wood chip bioreactor. So how much is the economics driven by nutrients being cheap, and is there a point where it starts becoming a way to get nitrate or phosphorus back on the field?
Okay, several questions there. First of all, was number 6 my favorite one, the drainage water recycling? I didn't even notice that. Yes, so that is a good one. So that has the potential for both. I think your question was, how is the economics of getting the nutrients back on the field in different ways working? And let me just say, with bioreactors, we are not, the wood chips don't capture the nitrate in any way. They're simply a home to denitrifying bacteria. That nitrate is gone. It's up in the atmosphere. So the wood chips will keep working as long as they don't disintegrate, and as long as they're kept saturated, they'll keep working. So nothing happens to them. The phosphorus, this is the whole problem, is that it doesn't go anywhere. So even if we do cover crops, for example, cover crops have so many benefits, but the problem is the phosphorus goes into the cover crops die. Now we have more phosphorus on the surface, not less. So this is a very unfortunate trade-off. I don't know if that gets at what you're thinking, but we need to keep looking at ways to do the ultimate, which is recycling, right? That's what we want to get towards, recycling. But recycling the water is probably the best way that we've seen so far.
We have a question over on this side.
Another financial incentive that I don't know if you considered in recycling the water would be pesticides, which are also expensive and persistent, such as atrazine. I know LSU did some studies on that. Is that something that you also looked at as an incentive?
The fact that the pesticides would be held in the water and recirculated, that in fact is one of our most troubling things, and we're looking for funding now to test it, because when I'm in a room with farmers, I just throw this out, could this work? That's something they're very concerned about, because with the herbicides that were applied to corn, for example, carry over, and if you applied it in the soybeans, would that be a problem? So they don't always want the same pesticide on the next year. I don't think that there would be enough to be a problem, but we need to do more testing. So I think it's unlikely that the pesticides would be seen as a benefit. It remains to be seen how much of a problem they would. But the nutrients are where the benefit is, and I didn't talk about that. But in most of the others, you can't keep the nitrate at the right place because it just moves so fast. But with this one, we should be able to. The ponds should not, if they act as ponds, not wetlands, there won't be a lot of denitrification. So that nitrate and phosphorus could potentially be a source for the next crop, and there would be financial benefits there. I've been thinking also in the energy, right? Because nitrogen, basically what it is energy. So as we think about the food, energy, water nexus, I think there's a good place, the amount that we can apply less nitrogen.
Got one back here and then Alan.
Yes, ma'am. You mentioned cost sharing being a kind of a driving force between how, how these are implemented. Are you seeing that this is exclusively cost shared? All of these practices, the ones that are successful to date, are all being cost shared, or are some of them being implemented out of the farmer's own pocket? How's the landscape look like that as far as where the funding's coming from for this?
Well, it's a very good question. I think there's a lack of data. And so, it's reasonable to ask those of us who are out in the field. Certainly with, for example, cover crops in Indiana, you sometimes have two sources of data. So NRCS knows how much they've paid for, and then they can go and do tillage transects. You can drive up and down and see how many cover crops there actually are, and there are more. So NRCS in Indiana is very pleased that there's obviously a lot of cover crops going in without their payments. For a lot of other practices, we can't know. right? So there isn't a source of data that would allow us to answer that question of whether people are putting it in on their own. There always is going to be some. There is a number of people for whom the whole process seems very onerous. But the reason I wanted to bring it up here is because the Nonpoint source programs work that way also, right? It's the challenge, people were talking yesterday, the challenge of Soil and Water Conservation District getting the money spent. It's not people's favorite way to work. So if there are other ways, that will certainly be more advantageous. We need more data.
Jane, you had mentioned that cover crops obviously have a value to the farmer in terms of soil health, among other things. And I'm glad you mentioned Indiana, because part of my question was going to be, one of the challenges we have in Iowa is we're having difficulty getting farmers to adopt cover crops. I mean, the most optimistic estimates right now is we have 500,000 acres of cover crops on 24 million acres of row crop land. Yet in Indiana, you've got, from everything I've read, 1 million acres of cover crops on 13 million acres of cover crop land. Why is there that difference, and what is it that we can do to encourage, educate, inform farmers that this is a valued added benefit to them? Because that is probably the single most effective strategy that we can deploy in Iowa if we're really going to try to tackle our nitrogen loss issues that we face.
Well, thank you for bringing that up, and it has been a great success, for which I can take absolutely no credit. I'm not one who does much with cover crops, so I just sit back and admire it. I think we can say that we've had a particularly dynamic and charismatic soil health leader in Indiana, who is now on the national staff, and there's just been a lot of energy there. The whole NRCS, all the districts are working on cover crops, so there's been so much cooperation, and other people from Purdue are part of it too, so it's just been a remarkable cooperation. I don't know if we have enough studies to say that, although Joe Schmies has his hand raised, so maybe he wants to speak on that.
I was going to say, we have Conservation Cropping Systems Initiative through the Association of Soil and Water Districts, and they have hub farms, farmers throughout the state that actually do, producer-led training on cover crops and that kind of thing. So I think that really helps that you have those localized, experts in cover crops that are also getting that out there.
Yeah, good point.
For maybe one, and then one last one here. I knew this was
With recycling nutrients being such a promising solution, and the difficulty often being the finances, has anyone done any analysis on how expensive fertilizer would have to become in order to make recycling nutrients, such as collecting the water and re-irrigating, more feasible and profitable to farmers?
Not that specifically. Certainly that we're trying to get more economic studies done, writing grant proposals as we speak, and I think that would be a good way to look at it. I don't know that fertilizer prices are likely to go up much, but just to know that might be useful. The way that we're thinking of it economically is that there's got to be a number of funding streams, right? So higher fertilizer prices could be something that drives it. And there's some benefit to the farmer through the reduced nutrient costs and the irrigation, which will become more and more beneficial. Then the public puts in some through cost share practices, either NRCS or 319 kind of programs. And maybe there's some others thinking about even with the stormwater programs. Now we're thinking, well, maybe at the edge of the city, somebody needs to put in a retention pond, and maybe that could be used. So we're just trying to think of multiple pathways that could lead towards that becoming more financially profitable, even as we try and get more demonstrations in so that we can collect the data that's badly needed to be able to answer the questions better.
I just wanted to speak to a couple of things that have been mentioned here. In Mississippi, one of the things the 319 program has supported and continues to support is we have a statewide as well as regional nutrient reduction strategies. And in Mississippi, one of the things that we've been looking at are tailwater recovery systems, which is something that you've been showing here. And we've done a lot of research and are at the point now where we're fixing to be able to publish the results of that research. And some of it is talking about water research, water reuse, and the nutrient value added to that. And then the next stage of that is looking at what is the economic value added to our farmers on being able to do that, because in our Mississippi Delta, we are looking at the water quantity benefits of tailwater recovery systems as well as the water quality benefits. So heads up, we are working with Mississippi State University as well as the USGS, and we are hoping to publish the results of some of these analyses within the next year or so. So I just wanted to let you know that in Mississippi we are doing a lot of practices on the ground, and we are doing a lot of really high-level data collection and research, water quality data collection associated with this, and we're hoping to get it published within the next year to 18 months.
Thank you, and if I can just add, that's one of the reasons I'm so happy to be here speaking at this national gathering. I'd really like to talk more with you, because I have been seeking out those Mississippi State researchers to find out if there are some lessons learned there. So if we can visit, that would be great. If anyone else knows of any systems, we'd really like to find more systems just to see what we can learn.
Yes, I think all of these are excellent BMPs, but what they are, to me at least, is a Band-Aid on the oozing sore of federally funded agriculture. We're not actually fixing the problem that causes this. We're remediating it. And I'm wondering if anybody has done any analysis or research on how eliminating corn subsidies would impact this. Would our farmers switch over to something that is less destructive?
It's a very important area of research, and there is research, and I think if people, one of the challenges is to get people thinking about even these different possibilities, but there is research, and here at the Nonpoint Source program, hope you're thinking about these questions too. Thank you.
All right, Jane, thanks again. A very interesting group of practices. All right, we're going to scale back a little bit to the project level here. We've got a presentation on unifying watershed management through an off-site BMP implementation program in the Little Arkansas River watershed. Ron Graber and Tricia Moore. See if I can find you here. All right, Graber. I might. Okay, and here you've got right arrow, or you can use the right arrow here, and there's a pointer. Here, you can use this one if you want.
That work? Hey, there we go. All righty, well, welcome. Thank you. We are going to tag team this talk, so there'll be a couple of us, and I'm going to do the kind of the intro or lay the background for you, and then Tricia will follow me. I'm going to get down here. Is that okay? I kind of move around when I talk usually, and I don't like to be tethered too much. So anyway, I don't know what exactly that says about my personality, but anyway, well, it's a pleasure to be here. Thank you, Steve, for the invitation. We have a project that we've been working on now for some time that to bring the urban citizens and the rural citizens together to address some water quality issues in the Little Ark watershed. And so just to begin with, I work as a watershed coordinator and technical service provider in South Central Kansas. Been doing that about 15 years now. I am an employee of K-State Extension. Tricia is part of our bio and ag engineering department on campus and has a teaching and research appointment, and urban stormwater is kind of her area of expertise. So we'll get started here and talk about this a little bit. So just a little bit of the background. The city of Wichita, the largest city within the state of Kansas, South Central Kansas, and they're required to have an MS4 permit, like a lot of cities. Sediment or suspended solids is kind of the issue that they are trying to address or required to address. Within the city, any development or redevelopment that's an acre or more is required to put some things in place to try to mitigate or reduce the amount of that sediment leaving the development site and ending up ultimately in the stream system. as many of you would know, those controls tend to be really, really expensive, and we're not achieving a lot of sediment reduction from putting those controls in place. And so about 2010 or 2011, a stormwater advisory board was appointed in the city of Wichita, and their primary goal was to look at the stormwater manual, kind of go through that, reevaluate it, and basically update it or revise it. Through those discussions, many of the folks that were part of that group started, having more and more discussions about these control measures that are going into place and how much they're costing, and just that whole the whole issue of addressing that. And so it came up in some of those discussions, is there some other way that we could address this issue, keep some sediment out of the stream system and make it a more economical and ultimately a better situation for all of the stakeholders or citizens of the area. So that's kind of at the point that I was invited to come in and begin to talk about some of the things that we were doing out in the rural landscape. Well, this is just some pictures of some of the things that are typically done in an urban landscape. And hydrodynamic separators seem to be very popular in Wichita. We tend to see a lot of those going in, and they're really, really expensive, as you might guess. But anyway, just some pictures there. So in Kansas, just to take another step back, our process of looking at these watersheds and trying to come up with plans is called RAPS, Watershed Restoration and Protection Strategy. It's a process that was put into place, I guess about 10 years ago, roughly, to bring local stakeholders together to just take a look at what's going on in the watershed, make some assessments, bring in folks that have expertise and are doing monitoring, and just try to come up with some local objectives and goals of how to address some of the water quality issues within the watershed, and either protect what's already there or make some improvements or some restorations. And so a written plan's kind of put together, and so that's kind of the process that we go through in Kansas. So the Little Ark watershed. So this is the watershed that's directly above the city of Wichita, and the one that for this project that really is the one that we're the most concerned about. So it's a primarily agricultural watershed. As you can see, about 80% cropland, so it's very intensively farmed and cropped. Not a lot of grassland. The crops are primarily corn, wheat, soybeans. We do grow some grain, sorghum, and those things. The makeup of those tends to change a little from year to year depending on economic conditions and other things. As you can see, we have a pretty fair number of registered confined feeding operations. I think my number may be a little bit high, but we do have a number of those, and again, that's primarily cattle operations, backgrounding, farmer feeder kinds of things, mostly the ones that would be less than 1,000 head. So we're pretty intensively farmed and a lot of livestock, and of course, along with all of that activity comes the opportunity for non-point source pollution, and we do have a number of issues that have been identified through the TMDL process that need to be addressed. And you can see, all of those are listed there, the bacteria, the nutrients, the sediment. Somebody asked a question about atrazine. That's pesticides. That's also one of our issues. The other thing in the Little Ark watershed is we do have an underground aquifer that serves as a drinking water source for the city of Wichita and other municipalities in the area, and also as a large irrigation source. So we've got some areas within the watershed where the water table is very close to the surface, as close as 5-6 feet in some areas, with very sandy, porous soil. So you can imagine that we've got a pretty good interaction between some of those activities that not just surface water issues, but also can become groundwater issues as well. The blue line, the Little Ark River that goes through there, dumps into the Big Ark River in the city of Wichita. So as you can see, any of the activities that we have going on in the watershed ultimately are going to affect the city of Wichita and that poor point at the where it dumps into the Big Ark River and then exits the south part of Wichita. So we've got really a lot of concerns from a surface and a groundwater standpoint. The other thing I'd point out here too is the city of Wichita has a recharge project where they attempt to capture high flows out of the Little Ark River, pump those back into the aquifer and for a later, for use later. So that adds another component there. So the Little Ark watershed, we wrote a watershed plan in 2004. In 2011, we updated that plan so that we could meet all of the 9 element goals, and we now are just about done or close to being done with a kind of a first revision of that plan. So in a fairly short amount of time, we've spent a fair amount of time evaluating and reevaluating, and I can tell you probably the biggest thing that we've learned is that we were too ambitious maybe with some of our goals that we put down in there. We have a 40-year plan to meet some of our TMDL goals, and 5 years in, 40 years isn't enough. It's not even close to being enough. We just don't have the resources that we need to get to where we, you know, and when we were all sitting around the table and talking about these things, it all sounded very reasonable, but it really wasn't. So anyway, the goals that our local group have outlined, atrazine at the top, and atrazine we began addressing in earnest in 2006. The city of Wichita has been on board with us and providing incentives from that point. The amount of money that they've made available to us to use the incentives has increased over time, and so we're what, 10, 11 years into that program. About 5 years after we started doing the atrazine, we started working on sediment in a little more earnest as well, and we've have diverted some of our resources and our time into addressing the sediment issues. The other issues, we just don't have the time and the resources to even make a full-fledged effort at those. So we do have our priority areas identified, and for the purpose of this project, we're primarily looking at the sediment. So here's our hucks that we have identified, and we have Tier 1 and Tier 2. So those are kind of the areas we're attempting to use most of our resources for to address sediment. So at this point, again, at the point I began attending most all of the stormwater meetings, and they were having those once a month. And so I got to be a very regular downtown city and meeting with those folks and becoming much better acquainted maybe than what I was with some of them. So we decided let's look at some of the costs of some of these practices that we're putting on out in the rural landscape, and what is our efficiency? How many dollars are we spending per ton of sediment reduction by doing some of the practices that we were all very familiar with: conversion to no-till, conservation till, buffers, cover crops, all of those kinds of things. What does it cost? So just kind of a quick snapshot, and this is a table that shows all of those things in there and kind of the amount of money cost per treated acre, and that would be the incentive amount. That wouldn't be the total cost, because most of these were at about a 50% cost share or incentive level. So, for instance, the $40 for no-till, a farmer would actually be about twice that much for him to implement the practice. But this was the amount of incentives that we're going to provide. Tried to look at some erosion efficiencies that our research at the university level has said are pretty reliable. Looked at, for instance, no-till. I think we used a 10-year life here, but we know that in most cases it's going to stay in no-till much longer than that. But for the sake of trying to come up with some numbers. So the number we came up with was a little less than $3 an acre to convert to no-till. So a fairly economical, and you can see in the others in there, those costs vary. We took a look at the urban ones just as a comparison, and here's that hydrodynamic separator that I mentioned a while ago, and about $25,000 to $30,000 to get one of those in the city of Wichita. About 0.4 of a ton per acre normal erosion rate within the city, and if you noticed on the previous slide, we used closer to 2 tons in the rural landscape. So you do the math, and here we are at $5,000 and something for a ton of sediment reduction. So this is when the Stormwater Advisory folks really got interested in having a little deeper discussion. At that point, the city of Wichita and K-State entered into a kind of a formal agreement to really try to put together a model and evaluate this and really get something concrete down. That's when we brought Tricia in, and she helped us with that. So I'll turn it over to Tricia.
Thanks, Ron, for the introduction. And
Well, Ron was talking about the RAPS program and a lot of their efforts in the watershed, and what was so exciting to me about this project was the opportunity to actually partner or create a partnership between the urban and rural entities to help carry out some of that 9-element plan and address some of the broader issues, including TMDLs in the Little Ark watershed. Of course, seeing these numbers, you can see that the city and the development community in particular were excited about this program because it offered a potential cost saving, so that we have kind of those two benefits running in tandem here. But based on some of those numbers, and the city decided they wanted to move forward with this, they needed some guidance as to some of the nuts and bolts of the program, how it would be structured, how it could work. And so I'm just going to go through some of the major points of that, and then how we have moved forward with this program since then. So one of the first major points that we discussed with the city was that we needed to have some sort of what we call a sediment credit ratio. So again, in this particular watershed, we're most concerned with sediment, though in other watersheds there could, of course, be different pollutants of concern. But the reason for this credit ratio was to basically account for some of the uncertainty we have. So we made a lot of assumptions in how much erosion we would have from an off-site versus, when I say off-site, it's rural or an on-site, an urban area. We also have some uncertainty as to how effective the different practices might be at containing any given pollutant, as well as if any pollutant that is contained at the edges of the field would have ever eventually even made it to the stream and contributed to that TMDL or other impairments. And so we came up with a sediment credit ratio of 2 to 1, which basically means for any amount of sediment that would be produced in an urban area, they would have to pay a rural partner to sequester at least 2 times the amount of sediment upstream. And that's kind of a common component of programs in water quality trading, and though this isn't a trading program, technically it's an off-site BMP implementation. We thought it would be appropriate to adopt a similar approach to cover, again, some of that uncertainty. One of the next things to hammer out were the types of BMPs that could be implemented in the rural area, again, to offset some of the water quality impairments caused by urban development. And when we first started talking, the city was really interested in going with some of the more permanent structural types of practices. So thinking of things like stream bank stabilization, which you can see over there on the right for you, or even things like conservation easements, which could be, having land in a permanent vegetated state. But based on, Ron's work with landowners in the area, we realized that those types of practices were either, in the case of stream bank erosion, going to be so expensive that it would be difficult to ever implement them, or be something, a conservation easement might be a little bit difficult to get landowners to buy into. So we really worked to help the city see how we could make temporary or kind of non-permanent practices a part of this program. So things like no-till with intensive crop rotations or cover crops or sorts of practices like that. And of course, the concern from the city standpoint was, well, if I pay a landowner to do this in 1 year, what if they decide not to do it the next year? And so what we did when we were figuring out how much they'd have to ultimately pay these landowners, they'd have to pay basically to ensure that they could, if someone decided not to do it the next year, that they would have enough money in the bank to then pay someone else to replace those acres, if that makes sense. That was kind of how we got them comfortable with some of these other practices, which, by the way, as we've heard, talking about soil health and some of these other things, have some other benefits that we get in addition to sediment reduction. So kind of the big thing after figuring out the types of practices and how much sediment would ultimately have to be reduced was to think about how much money would have to be generated. And so the funding source for this is maybe still kind of up in the air in terms of how they do that, but the idea was that basically they would ask the developer of a new or redevelopment property to decide if they wanted to either put into place an on-site type of urban green infrastructure or other sort of water quality practice, or to pay into this fund that would ultimately fund landowners upstream to implement different BMPs such as no-till. And so we came up with a spreadsheet to help the city kind of think about all the different factors that are going into play here, one being, for instance, the amount of sediment that we assume is being generated from an urban site versus the amount that we assume is being generated or can be captured off-site, as well as the type of practice and the cost of those practices. And the final number, so this we assumed that this program could be structured based on probably the most common type of BMP, which we were likely to have upstream, which was no-till. It's pretty popular, and Ron and his group have had good success in getting landowners to adopt that. And so based on that, we came up with a rate of essentially about 50, or a payment that would be equivalent to about $50 per ton of sediment removed, which when you then bring that back to some of the assumptions of how much sediment is being generated on site in an urban area, it comes out to be, it costs the developer about $37 or $40 an acre to buy into this program. And so what that payment would get for them would be the exemption from doing an on-site type of practice. So that practice in the middle is a hydrodynamic separator, which is probably one of the most common types of water quality practices that developers in the city of Wichita tend to like implementing. Though they do, for larger developments, the city still does require that they take care of their peak rate control, so reducing flooding. So that still requires some of the larger properties to put in a pond or some sort of detention structure. Okay. So in terms of how the incentives then could work for this, if you have one of those larger properties where you're already doing a detention structure, it doesn't cost that much more, you know, to build some water quality function into that or to get some water quality benefit. Whereas with the hydrodynamic separator, that's just there solely for the water quality benefit. So, or in my opinion, a very nominal water quality benefit, but if some of that it goes in there. Versus scenario 3, which I'll show you for a developer who might opt to just buy into the program and pay someone upstream. And kind of the cost for those, again, and you kind of saw those in the previous slides, but the take home here is that in general, it's going to be much less expensive for a developer to buy into this off-site program if they're just purely looking at the economics of it. All right. Just to show that graphically, you can see over time, so the blue line is showing if we had a larger development that already has some sort of water quality pond. The difference between the solid blue line and the dashed blue line would be the solid blue line is where they've added some additional volume to that pond to get some of the water quality credit, versus the dashed blue line is if they've just bought into this program, which I forgot to mention is an annual fee, so about $40 per acre per year. And so you can see that over time, you know, those lines cross, but still initially certainly probably a cost savings for whoever would be developing that property. The orange line is showing for, again, a hydrodynamic separator, which would be common for a smaller type of property. And in that case, the cost difference is probably sort of a no-brainer to go ahead and participate in the program. So I guess that's kind of the nuts and bolts again of the program. So we just wanted to give you a little bit of an update as to where the program stands today. And so Wichita has gotten permission, has actually written this into their MS4, their municipal stormwater quality permits. So they do have the option now for the on-site kind of traditional stormwater BMP option, or to go with this off-site option, which again we're thinking, given enough time and enough money, could actually be addressing some of these more broader, holistic watershed water quality problems we have. But of course, they're still doing this within their stormwater management plan and still requiring some of the other essential items from a property, like controlling peak rates and flood control. But just kind of a messy diagram, this just kind of show the flow of money and work. But developers would make a payment to the city, which would then go to Ron's group at RAPS. They would then be able to get landowners signed up who are in some of those priority areas, so areas where we know we have more sediment and pollutant contributions coming into the watershed. And then there'd be some reporting from the city back to our state regulatory agency and ultimately EPA as part of their MS4 permits. So just a little bit of what it's taken, or some of the players in this program. Of course, we had to have stakeholders buying into this, so this was both our state regulatory agency as well as the city, and then, of course, having landowners upstream, so kind of the real off-site participants who would be willing to play in this as well. I think a critical component for a program like this to be successful is to have, again, kind of this watershed vision. And so we had the RAPS program and Ron's group, but really some feet on the ground that are already have some relationships with producers and are able to get some of these practices in the right places in terms of targeting some of these water quality impacts. And hopefully as this program moves forward, we'll have the opportunity to do some monitoring to look at how effective it actually is. We have a nice spreadsheet with a lot of assumptions, but it's always good to have some validation as to whether or not we're making progress on goals. And I think that's it. So.
All right. Very interesting project. I know there's at least one stormwater city I work with who's going to be very interested in this.
Ron, question for you. Are the producers in that watershed, I assume there's been no-till for a number of years. I'm just wondering, what does it take to get producers who aren't no-till producers to switch over to no-till adoption? And when they do that, do they go whole hog, or do they still have some conventional tillage, or how does that work?
Yeah, so the question was how eager are guys to switch to no-till, and, kind of how does that process go? And, it was mentioned about the relationships, and we very much are in the relationship building mode. There's another fellow that works with me that does a lot of our kind of in-field farmer contact. I like to call him our evangelist. He's about my age. He lives in the watershed, has all his life, farms a little bit, and worked for the co-op for many years doing precision ag and other things. And so we really attempt to build long-term relationships with these guys. We see them in church. We see them at school board meetings. We see them in a lot of places, and it's a relationship and a trust and a process. And so when we start talking to these guys, most of them don't go whole hog initially. They do one or two fields. Our guys, much like a lot of areas within the country, are getting bigger and bigger all the time. A lot of them are farming 2,000, 3,000, 4,000 acres, so they're not going to make that big switch all at once. So we get them to kind of start participating, watching their neighbors, and and very often with no-till. And as Tricia said, one of the big discussions with the city of Wichita is, the concept of paying for a management practice was just really difficult for them, and that's why the model is built so that the dollars would be there to replace 100% of those acres every 5 years. We don't think that will happen. In fact, we know it's not going to happen. We're closer to probably 80% staying in no-till, especially if we can keep them in several years. So, we have not had a hard time finding enough acres to utilize the dollars we've had available through our RAPS program, and that's one of the things that's really attractive to me about this program is it's another revenue source that we can get more of those acres in, and they'll be signing they're signing a 5-year contract to go with this program. And so the fee that the city ended up agreeing on is $19 is what the developer is going to pay, $19 per acre for that developed acre, and that'll be a forever thing. The city chose to put in $60,000 to kind of a startup deal to get this program going, so we could kind of get a bank of acres established, up front. And we started about 2 months ago, and as of last week, there were 76 acres within the city that have indicated they want to participate in this program. And I might mention as well, and I think this is really interesting, is some of the folks. This is beyond your question, sorry, but there's some of the folks that already have these separators and these other things in place said, "Gosh, I'm currently having to maintain the system that I put in. Plus, I'm giving the city $500 every other year for inspection fees and all that sort of thing. How do I get into this program?" The city has agreed to allow them to opt in at the $19 an acre figure, and they will maintain that separator or whatever it is that's there. And so there are folks that are coming forward you know, in those situations as well. So, you know, we think that it's going to be a popular option. Yeah.
Okay, well, we've got one more right here, and I think we're going to have to break for lunch. Are you guys going to be here for a few minutes? Okay.
Yep. On the urban side, 2 quick questions. Are the developers off the hook for any stormwater controls? I mean,
no. So not any. So the way that the MS4 permits are administered, they deal mostly just with the quality, at least Wichita's does, and so they're off the hook for any practice that gets credit as a water quality practice. But they still have to do something that's going to control. I think they have to do the 2-year, 10-year, 100-year peak flow. So there is still some requirement.
I was a little nervous about that.
Yeah.
And then
that
on the
really
second
bad.
piece, the cost that you used for those tables on the urban practices, were they retrofit cost or like integrated stormwater cost? I mean, because the cost of new construction and integrating low-impact development practices is way lower than retrofit costs.
Mm-hmm.
So.
Yeah, it was assumed that they were new developments, but a lot of the disparity in the cost is just because of the sediment load that's assumed to come from an urban setting versus a rural setting. So that was the primary driver.
All right. Once again, thank you, Tricia and Ron. Very good. And we are going to break for lunch till 1:30. I apologize for not having enough time for more questions. We could probably be here for weeks. We'll see you back at 1:30.
Lunchtime slumps. I'm Fred Suffy, and I'm the Region 3 Nonpoint Source Coordinator out of Philadelphia. Some of my other counterparts that have a lot of urban-related work, we feel like we haven't been given the time during some of our past national Nonpoint Source conferences. We think that urban has kind of had a backseat to agriculture, and so thanks to Sandra and the Region 1 folks for bringing the meeting here, and now we get to showcase the urban-related efforts and give urban-related Nonpoint Source the respect it certainly is due. The session today is going to really show you about the complexities, if you're not familiar with the urban work, and how complicated it is, how many partners it really takes to get the job done, and how long it takes to get some of these projects done, as well as some of the innovative thinking and technologies that our 3 speakers are going to be talking about. And I'm thankful that we've got really 3 very esteemed speakers to talk with us today about urban Nonpoint Source. So I'll get started because I know each of them have way more than 20 minutes to talk about. So our first speaker is Steve Sari from District of Columbia.
Hi, everyone. I hate standing at podiums, but I guess I'm stuck. So, how do I do that? Is that better? I don't want to lean over. Oh, awesome. I can walk. So then I need someone to deal with slides. Okay. So, yeah, my name's Steve Sari. I'm with the District Department of Energy and Environment. And why am I here? Because I think I probably am the one jurisdiction that is 100% urban of all of our Nonpoint Source areas. So I have a lot to talk about in terms of that. I wouldn't say that it's because of my good looks or my speaking ability. So what I do in terms of planning a presentation, you know, just like any best man, I thought about, okay, I'll Google like some sort of quote that'll have something to do with innovation and challenges, and I came up with this. And then, of course, I added cat pictures because everyone loves cat pictures. So a little bit about the District of Columbia. The DC is a diamond-shaped jurisdiction that is 10 miles by 10 miles square. Actually 68 square miles total because we gave part of it back to Virginia. our colleagues from Virginia are happy to have it back. Good riddance, I say. And we have 680,000 people in that 68 square miles. That means that we have about 10,000 people per square mile. About a third of that land is federal land, so we have to deal with our federal agencies a lot. And a third of the land is combined sewer system, while 2/3 of it is separated sewer. So now you know a little bit about the background of the city. What I want to do is essentially walk you through some different areas that create non-point source pollution, some of the challenges that we faced in addressing non-point source pollution in those areas, and some of the ways we have tried to address it, and some of the things we've learned along the way. So I'm going to start small, and what I'm starting with is residential areas. District has a ton of land. The most of our land in the district is residential, and we would not be able to achieve our non-point source pollution goals without addressing pollution in these areas. The problem in this area is, A, there's just a lot of properties, and the average size is like 1/10 of an acre. So we have a lot of people we have to work with, and we have not much area on those properties to work on. The other thing is, this is an area that is the slowest area for redevelopment, and these areas don't trigger our stormwater regulations when people are building on those properties. So that means the only thing we have to work with is incentives. So because of that, we have developed a number of incentive programs, and we started with rain barrel giveaways and tree planting giveaways. What we found is that a lot of people in DC don't own cars, so they can't really carry these things back. The other thing is they don't know a lot about what to do with these things, so we're giving them away and they're not installing them or installing them properly. So we took those initial failures and revamped them to come up with a program that we call River Smart Homes. It's 5 different items that we offer to homeowners. And the way the program works is homeowners get in contact with us. They, either by email or phone, they get on a waiting list. We go out and schedule a time to visit their property and do an audit of their property. We teach them about stormwater pollution, teach them about what things can be done on their property. And if we stop right there, we feel like it's a victory. They have learned something, and we have reached a lot of people and given them an intensive 1-hour session on stormwater, which is what you guys are getting today. So, you know, they get what you guys are getting. However, if they decide to take the next step, what we do is we provide them an audit report, and they can just, you know, take that and throw it in the trash, or they can actually act on those things and request some of these things to be installed. If they do that, we pass that information on to our grantees, who work with the homeowner to get the BMPs installed. And we will pay up to $2,400 per property to install rain gardens, rain barrels, trees, all the things that you see up here. We designed the program to not trigger our regulations so that that made it easier. We didn't have to go through permitting. That saved us time, saved us money. And then lastly, we also developed a rebate program. So this is the River Smart Homes program is us going out and doing the installs. But if people want to skip that line and that wait and know enough about stormwater that they feel comfortable doing this work through contractors on their own, they can do that and then pay for it themselves, and we will reimburse them for that work. So what did we learn? Kind of covered some of them already. You know, it's easy to give stuff away. People love free stuff. It's harder to get them to use it properly. And people don't really understand this, so they don't know where to get the information. They don't know who are qualified contractors. So we made it easy for them. We designed the program so that they did not have to know these things. We provided it to them. And again, they don't know this stuff, so we need to follow up with them. We keep a list of the homeowners and what they've installed on their property. And then we provide targeted messages to them. For example, in the winter, hey, it's time to drain and disconnect your rain barrel so that it doesn't freeze and crack. Or in the summer when it's been very dry, you need to water your tree that you had planted this year because it's going to be stressed. Or, hey, there's a big rain event coming. You need to drain that rain barrel prior to the rain event so that it can capture that stormwater. And what we do is we, build this up and build good habits in the homeowner's minds. Okay, so moving from small lots to large lots. Unlike homeowner areas where we do have limitations in space because they're small properties, here we have limitations in space because the properties are doing lot line to lot line development. So it's really hard to work there. Additionally, when you're installing these BMPs, they're a lot larger. There's a lot higher upfront cost to the property owner if they're going to install them. And prior to our stormwater regulations, there was really not much incentive for people to go back and install these things. Not only that, there were impediments for them to doing it. For example, we had plumbing code issues that they could not install cisterns and reuse it for toilet flushing or air conditioning or things like irrigation on their property. And again, just like the homeowner areas, proper installation and maintenance was an issue. And so we were always having to follow up with them to make sure that it was done properly. And I'll talk a little bit more about environmental justice further on. Just going to put that in there as a placeholder for you. So what are some of the things that we've done? We have put in place very stringent stormwater regulations in the District of Columbia. Anyone who disturbs over 5,000 square feet of property of land has to control the 1.2-inch rain event on their site. And what that amounts to is a 90th percentile rain event. Also, if you disturb less than that, but you're doing major substantial improvements to your property, you have to still achieve some level of stormwater. You have to capture the 0.8-inch rain event on your property. So it's a little bit less, but you're doing a little less disturbance on your property. Additionally, we have stormwater utility fee, which is based on the impervious surface on the land. So we have a couple of sticks. There are regulations and this fee. We also develop carrots for property owners, one of which is a green roof rebate. This is something where we offer $10 a square foot throughout the city to retrofit your property with green roofs. If you are in our targeted watershed areas, which we have targeted watersheds where we are doing stream restoration work or have done stream restoration work, where we want to also do upland LID, and we offer $5 additional, so $15 total in those areas to get people to install green roofs. We also have River Smart Communities, which is a lot like River Smart Homes, except for larger properties, so condominiums, churches, synagogues, businesses, where we offer same sort of incentives. The difference being that the property owner, we do a 60-40 cost share. We pay 60%, they pay 40%, unless they're in the targeted watershed areas where we'll pay 100% of the cost for them to retrofit that property. Also have developed something called stormwater credit trading. This is where that environmental justice issue comes in. Property owners, it's very expensive to retrofit downtown areas, as we talked about, very densely developed. But that's where a lot of the development's occurring. So we have this environmental justice issue of that's where the development occurs, that's where the greening occurs, and the poorer neighborhoods in the city are left out. So what we have done is develop something where a property owner downtown can do part of their stormwater requirements on their site, but then can also do greening elsewhere in the city in areas where it's more cost effective for them and produces that environmental justice of reaching people, communities that are not currently being served the way they should be. So they still have to meet that 1.2-inch obligation, but they're meeting part on their site and part on another property. We also have something called shared stormwater facilities, and I'm going to show you that here. So this is you can't really see it. The picture up above is this site down below. What we've done is allowed property owners who normally have to treat their stormwater on their property, they can treat it in a shared facility that where all these buildings here are, the stormwater from their property is draining into this parkland where it goes through bioretention cells, goes into a cistern, and then is reused for irrigation. It's also used, we have an ice skating rink and a fountain play area. And this is called Canal Park. If you guys ever in DC, I highly encourage you to visit and geek out on it. It's really cool. So what have we learned? Some of the hard lessons we've learned is that financing is a lot harder on these large lots. You know, even with the amount we'll provide for them, it's not necessarily enough to get property owners to pull the trigger. Additionally, property owners prefer simplicity sometimes over the cost savings that they would have of having a reduced stormwater fee. They'd rather have asphalt that is easier for them to maintain than some sort of bioretention cell they're going to have to do work on sometimes. On the positive side, what we found is if we spend a fair amount on these practices that we're installing and they are really beautiful, people will flock to them and they will maintain them. They become something of a showcase for the property owner, and they do a much better job of maintaining them. Okay, so I think I'll make it through this one and then I'll stop after this. So another area that we have seen significant challenges, and probably the hardest place but the most important place for us to work, is in the right-of-way. You can see some of the issues that face right-of-way. We have a lot of constraints in terms of utilities that think that they own that area, but the district actually owns that. We also find that people think that they own the road, and not just because they're driving on it. People whose houses are right next to the, whatever road they're right next to, they think that they own that parking space in front of their property. It makes it very hard to work in those areas. So what are some of the things we've done in these areas? We have worked to do full sewer shed retrofits. We don't just do piecemeal BMPs here and there. We target areas, so areas where we have flooding issues, areas where we've done stream restoration, areas that are uphill of other roadway projects. And I'll explain that more fully as I work towards close. We also do pre and post implementation monitoring. This really helps us sell these projects to the property owners. And we're not just monitoring the stormwater reductions that we see there, we're also monitoring the different types of practices that we use to see which ones are going to last the longest. And it's not always what's the most cost effective. Sometimes there are other reasons that we're seeing that we want to use those versus other things. Also developed a roadway guidebook for retrofits that we did concurrent with doing a restoration project. And this is really helpful because it wasn't esoteric. It was us actually doing stuff out in the field and saying, oh yeah, that didn't quite work. We need to modify what we had in the guidebook to make it fit better with real world conditions. So what do we learn? Public acceptance of the concept. People love greening. They like the idea of their neighborhood being a very green area. That doesn't necessarily translate to them wanting a BMP in front of their property. A very small lesson we learned is, on those corner lots, which is the places where oftentimes we're installing these BMPs, you don't want to install a BMP on the front of the property because that's where people park. You do it on the side corner of the property if you can do that, and they're more accepting of that. Long-term maintenance is super difficult and super crucial, and there are two reasons it's super difficult. One, construction is always going on in the city, and where does all that erosion and material go to? It goes into the street. And where are these BMPs located? They're located in the street. So because of that, these BMPs are getting inundated with a lot more material than other BMPs. So it means you really have to stay on top of the maintenance. The other thing is, roadway is dealing with not just the stormwater that falls on it, it's also dealing with the stormwater that's coming from off-site. That means that you have to design them in such a way that they are dealing with more material, and you either have to pass through that system or you have to design it differently to be able to capture that with sediment forebays and things like that to capture some of that material so that you aren't having to maintain it like after every rain event. And this is super difficult. It's a really hard lesson that we are continually having to modify our design. So just for clarification, is that 5 minutes like questions at this point in time, or I still have 5 minutes to go before? Okay. So wait, I should stop for questions now, or 5 minutes? Okay. Okay. So we were just talking about only happy when it rains, and it's because of garbage. Here you go, right here. This is everything that comes from those roadways, those rooftops, those small lots is coming to our streams. And so our challenge here is just the massive amount of stormwater that we're getting into these systems. We obviously have to do a lot of work upland, but that's going to take a lot of time because there are a lot of property owners and a lot of damage to undo. So you can see the type of challenges that we have here. We have an additional one in the District of Columbia, and that most of our stream valleys are owned by the federal government, which means that all of our projects have to go through NEPA compliance, which means that it adds time and money to every project. And if anyone can help me address that, I would be happy to hear it. So what are some of the things that we've done? We've installed trash traps. DC is one of 2 jurisdictions, I believe this is correct, that have a trash TMDL, Los Angeles being the other. So when we're doing stream restoration projects, a lot of times we're installing trash traps upstream to capture that trash before it gets into our streams. Also have been working on a type of stream restoration called a regenerative stream channel design. And this is, like, from my perspective, an amazing stream restoration / BMP that captures stormwater, infiltrates stormwater, recharges groundwater, and which then provides base flow during the summer months for these systems that are often starved of water. It's also treating a lot of the pollution, and it's not working just on that stream corridor that we work in. It's also helping reduce the issues downstream from that stream corridor. And we've done a lot with interagency coordination. When we do these projects, we work with our water and sewer authority so that they upgrade the sewer lines at the same time we're in there, so that we're not going back in there. And we do a lot of upfront monitoring. And again, this helps us tell the story to our regulators that the success of what we've had, and it helps us tell the story to the public as well. This stream here is the regenerative stream channel. You can see there's 2 pictures from the same location. We had about a 10-foot eroded channel, and we've restored it to this area. 2 years ago, we did this project, and before we did the project, we had 0 amphibians in this system. Afterwards, 2 years later, we did not seed these. They came all on their own. We have 6 of the 12 species of frogs that we find in the district are already colonizing the system. So that's the type of story we can really tell. So one of the things that we've learned on the design side, we found that our models way overestimate the stormwater in these systems. They design these systems based on engineering calculations that assume that streams are pipes. They are not. They are very rough, and stormwater flows through them very differently, much differently than a pipe. Designers also always underestimate the material needed in these restoration projects, which really drives up our costs. So we always are now adding, double to what the designers tell us the cost is going to be. Also, if we can add public access to these stream projects, we have a lot more support for them because people see them, they love them, and they begin to make the connection between this beautiful area and what they can do upstream. So it's crucial for us to do these projects because it helps those upstream areas. So I'm now going to skip to the very end. I wish I could talk about trees. So to be effective, these projects have to be concentrated. And what we do is we're doing the stream restoration and trying to do low impact development in the areas just upstream of that. Stream restoration can be an easy early win because we're dealing with one property owner, not hundreds of property owners. It's also a lot less expensive to do. And our upfront monitoring, we believe it pays dividends long term. We spend a lot of money, and sometimes it can be up to the quarter of the project cost on monitoring. And what we want to do is do that one time, show that this works, gives us proof of concept, and then we are going to our EPA regulators and saying, hey, this is an effective practice, and we don't have to prove it every time we're going out. So I'm going to leave it at that. All right. Thank you guys very much. Oh, I have one.
Don't go too far. All right, questions for Stephen?
Hello. So you talked about different design elements that were effective for stream restoration. How about for bioretention or even porous pavement? And is DC documenting this information, or do you know other cities that have documented this information in public documents?
So yes, we do have both a green infrastructure, our stormwater guidebook is online, and our Department of Transportation also has what they call a green book, which is their green infrastructure for right-of-way. And it does have a lot of innovative practices that we are continually updating. In fact, we are working on updating the BMP guidebook now.
When you do the stormwater credit trade-off to address the environmental justice issue, who ends up being responsible for maintenance on the off-site EMPs?
So it depends on how it's set up. You know, so it can work in multiple ways. One, the property owner who is developing in that downtown expensive area, they can seek out a property owner somewhere else and negotiate with them to do a project on that property, in which case lots of times that property owner say, fine, but you're going to have to maintain it. Also, we are finding that what's more common now is that people are starting to retrofit these areas on their own with the idea that they can sell the credits on the market. So it becomes something that not only creates green infrastructure and beautification in their neighborhood, but it's also something that generates money for them. In that case, generally if they are trying to sell their credits, they are responsible for maintenance of them. And we have a very detailed system that tracks who's responsible for maintenance, and we make sure that that's happening.
You mentioned a little bit about coordinating with utilities. I'm wondering if you could expand on how you get, roads, utilities, how you bring all those groups together to fund and make an efficient process.
Yeah, so this was also a part of when we were doing our first widespread retrofit area. We met with all the utilities and talked, we didn't just, we walked through the sites with them, talked about what we were planning on doing, and talked about conflicts with them. And for the most part, we actually found that most utilities were totally okay with us working through their system. They had maybe some modifications that we needed to do, like our gas infrastructure. They were fine if a bioretention cell went right through that, but they wanted us to put a sleeve around it. So it just, just produced a little bit more safety factor for them on that. There were certain things, like our Water and Sewer Authority is very much worried about water from our stormwater facilities going into their sewer lines. Personally, I think that if our water is going into their sewer lines, I'm as much worried about their sewer lines leaking. But That's not going to get in an argument with them. So what we do in those cases is we put a lining over the top of just the portion of the bioretention that is over that sewer line.
Just to expand the previous question regarding environmental justice, how do you build an inventory of interested property owners? Or how do you even know which parties are interested in doing what you have to offer?
So a lot of different ways, and this is, I kind of skipped this on one of my slides where I said that sometimes government is not actually able to do the work, but what we can be is a facilitator to connect interested parties. So we do maintain a database of parcels that are interested in this. We also, a lot of our River Smart community sites, like I was saying, they are, sometimes it's too expensive, even though we're paying 60% for those property owners to do the 40% cost share portion. But we have an audit of that property, and if they're interested, they can go to someone, they can say, hey, we're interested in having our site be one of those sites that gets retrofitted for that type of credit, and they already have a plan for that site that we've provided to them. So, you know, we try and make those connections.
All right, Stephen, thanks again. Great presentation, great quotes, and great pictures. All right, yeah. All right, our next presentation is from the great state of Iowa. Darren Muring with the City of Dubuque, Saving Green by Going Green. We're going to hear about the B Branch Watershed Flood Mitigation Project. Okay. Yeah, if you do the presentation mode, it'll pop up right there on the screen. Little icon, right? Oh, you know what you got to do? You got to look up there and go all the way to the left, and then all of a sudden it appears. I was learning on this myself yesterday. There we go.
Good afternoon. Feel a little sheepish being up here, not because I look at the EPA like wolves or anything like that, but I mean, just to think, you know, to be in the presence of people who have either dedicated their lives towards improving the water quality of creeks, rivers, streams, lakes, or people just starting out, and to think that, you know, you might learn something from what we do in Dubuque is kind of humbling. I guess the other thing I would say is that a lot of times we get together in workshops like this, it kind of can invigorate people, and you get together and you share stories and you kind of re-energize yourself. So one of the things you might learn about my presentation is that there are places in the world and in the country, small communities, where we're doing things that are improving watersheds almost by accident. So that's kind of a positive thing. So just if you don't know, Dubuque is located right on the Mississippi River, right at the corner where Illinois, Wisconsin, and Iowa come together. We recognize in Dubuque, you know, where we are in our watershed as well. We partner with many of the few organizations that our mayor is a partner with, communities up and down the Mississippi River. Again, recognizing our role, you know, just in terms of watershed management, and it's bigger than just us. But also just more on our level, community-based. What you see here in red is our corporate limits. We're about 30 square miles in size. And that's shown in red. And the B Branch watershed is about a 6.5 square mile watershed. While it's only about a quarter of our size in terms of the total area of the city, half of our population either works or lives there. So it's obviously a very important part of our community. The other thing you'll notice too is that it's all within our corporate limits. So that's kind of a unique situation where we don't have to struggle with other jurisdictions, and we can kind of affect change on our own. Just kind of zooming in, you start to get a sense of what the topography is, where we have the steeper slopes and then some flatter areas. So we're right on the Mississippi. We have these. We're in what's known as the driftless region along the Mississippi River, where the glaciers the last time they came did not affect our town, so they didn't flatten out areas like a lot of the Midwest. So we have these steep bluffs, rock outcroppings, and what that does is it creates steep slopes from certain parts of the community that shed water very fast, and then it sheds it towards the flatter areas next to the river where it can tend to flood. and so we get the sense of this. It rushes off very quickly. It gets to the flatter areas where it cannot drain out as fast, and then it starts to flood. And one of the very first things that I started doing, I've been working for the city of Dubuque for about 18 years, and one of the first things that I did was write a request for proposals to hire an engineering firm to look at the flooding in our watershed. And so in 2001, the Drainage Basin Master Plan came out and addressed flooding in the Bee Branch watershed. We weren't addressing water quality. That's not our, wasn't our purpose. We were to look at how can we address this flooding. There was some lip service to the, the NPDS Phase 2 rules that we had to comply with in a couple of years, but that was about it. This just kind of shows the impacted area, predicted flooding, so about 1,500 properties or so. This just shows that flooded area in the watershed. This was an independent study by FEMA. They were essentially updating our flood insurance rate maps in 2011, so they kind of did their own modeling and came up with about 1,300 or so properties that were in the flood-prone area. And this is what we've actually experienced. So each one of these represents a presidential disaster that was declared starting in 1999 through 2011. We've had 6 of them. And that essentially just means that the damage was such that the community and the state, it's more than we could typically be expected to recover from on our own. But you see the very last one there in 2011 was 10 inches of rain in 12 hours. Just to put that in perspective, our average annual rainfall in Dubuque, Iowa is about 36 inches. So we received about a third of our annual rainfall in a 12-hour period. Just coincidentally or just anecdotally, in Dubuque it's been very wet over the last few years. I just recently looked into the rainfall records of our community, and 2 things that were striking. July of 2011, so obviously with this big rainstorm, July of 2011 is the wettest month in our recorded history. The 3rd wettest month in our recorded history is June of 2014. So 2 out of the 2 months in the last few years out of 1,400 months were our wettest. Also, 5 of the wettest months have occurred in the last 10 years. So we've really seen an uptick in the amount of precipitation we're dealing with, and obviously with the disasters. So the estimated damage, a lot of this is proprietary, so we have to do it based on estimates. We don't necessarily know what the property damage is, but we estimate based on the extent of the flooding. So as part of this, we had that flooding. We updated our Drainage Basin Master Plan in 2013 due to this increased flooding. And again, we're doing this for flood control as our primary purpose. So we were attacking it in multiple ways. One is volume. Our problem is we have too much water all getting in the same place at the same time. So the volume reduction, we're going to try and reduce the amount of water that gets there. Rate and timing, we're going to try to make sure it doesn't all get there at the same time. And then conveyance, once it does get down there, how do we safely move it through the community without creating problems? So the combined, benefit of that will save and avoid almost $600 million worth of damage over the life of those improvements. So just to quickly go over these, this is the watershed. Everything in color here represents improvements we're making throughout the watershed. So volume reduction, essentially what we're doing is we're redoing every alley in the watershed, 240 of them, with pervious pavement systems, with porous pavement systems. One of the things that's unique about Dubuque, I mentioned the steep slopes and the rocky and steep bluffs is, and we actually had to, the question from the city council member who pushed against us using pervious pavement systems for flood control. His point was, he goes, well, the Iowa Stormwater Management Manual says that slopes should be gentle or flat, half of a percent to 1%. And we have places where they're 7% or 10%. So we shouldn't be doing them. All the manuals say you shouldn't. So one piece of advice is make sure when you provide input on these manuals that you asterisk those statements. Because obviously that's the ideal situation where you would build these alleys, but it's not to say you can't do them. Basically our explanation to the city council was, well, we have steep terrain in Dubuque. A lot of things that we do here is more difficult than other places. So this just shows a couple of examples. So essentially you just have to, what can happen is the water will go into the ground, and if you have steep slopes, it'll start to hit an impervious area and start to move laterally and flow underneath the pavement, get to the bottom of the hill, and then blow it all out. So you have to create these areas where the water can't move laterally and promote infiltration. We've also, as part of our watershed project, we have a full-time dedicated person for outreach. So one of the things that they do is this, we have a green alley story map where people can go on and click on the alley that might be by their neighborhood, before and after pictures, or they'll also see the schedule as to when their alley is supposed to be done. We actually assess our alleys just like we assess our street projects. And for many, many years before I started, the city will assess 15% of the street, and so we carried that over to the alley system. So actually our residents are paying 15% of the cost to redo these green alleys. At first there was some pushback, but it's about $600 to $1,000 for an assessment. If they can't pay it back, then it rolls onto their property taxes, where it gets paid off over 15 years at 3% interest. So it's very affordable. It's like $60 a year, $80 a year is what they increase their property tax bill. So pretty minimal. And so now we actually have people who are, when's my alley going to be done? So they're very excited about it. Rate and timing. Again, this is detention basins. Again, here we're trying to do flood control, and what we essentially did is we created an embankment, or as the Department of Natural Resources would classify it, a high hazard dam. And all we do is, you see the blue area there, well, that's actually dry. It's just a wooded area up along a creek, and then when it rains or have these rainstorms, then the area will be inundated and slowly drain out. But what we've actually done is we preserved these 12 acres of woodland, riparian landscape. We've also we've obtained easements for this area, so this is basically going to be this way for the foreseeable future. And then downstream, another detention basin. So a lot of detention basins, and people will have a secondary use. They might have a soccer complex or baseball fields or what have you. But we actually chose to redo this as more of a natural area within our community. We look at the proximity of this improvement. It's only a couple blocks away from the actual flood-prone area. One thing about our flood-prone area, it is our more at-risk neighborhoods, our low to moderate income neighborhoods, has a higher percentage of minority populations, and this gives them, an area where they could just, within a walking distance, almost experience like you're out of town. Deer or other kind of wildlife will go in this area. But again, preserving, enhancing riparian landscape. Again, we didn't do this project to improve the environment or to improve the quality of the creek or the Mississippi, but obviously in doing so, we actually are. This is one of the first projects we took advantage of the State Revolving Loan Fund, and they've been a huge player in what we've been able to do in Dubuque. And then conveyance. So now the water gets down to the area. Well, back at the late 1800s, there used to be a creek that flowed through the area, and then due to flooding, they thought it was a great idea. Let's bury this, and then it won't flood anymore. It worked for a few decades, but obviously those disasters, I think the sewer can handle like a 7-year storm. So it's obviously been undersized ever since they buried it. And so one of the things we had to do was try to increase the conveyance. So how do we do that? And immediately we said no to this. And did we say no because, well, we said no because it was too expensive. We couldn't afford to do this. So we basically had said yes to this. Again, not because we're trying to improve the environment, not because we had this grand scheme of daylighting this creek. It was cheaper. It was less expensive. It also, we hoped, would open the door to use, again, have a nice low-interest loan through the State Revolving Loan Fund to help fund it. One of the things working in urban environments, so Dubuque is the oldest community in Iowa. We were actually incorporated in 1833, so it was actually incorporated before Iowa became a state. So obviously we have a plethora of old historic buildings, homes, what have you, And so, and in fact, it's who we are. So we are very versed with the Section 106 process and how you go through that. And so there's no way we could go through the community without impacting, you know, homes that were, some of them, over 100 years old. So one of the challenges we had was we knew we were going to get a Corps of Engineers permit because we were working next to the flood wall levee system as part of our daylighting project. We wanted to use SRF, which is administered by the Iowa Department of Natural Resources. And so we packaged the stuff up and some information, you know, try to get ahead of the curve and get the stuff off to SHPO, and they basically returned it unopened to us. They wouldn't even look at it because we weren't the lead agency. The problem was the Corps of Engineers is like, well, if you're going to use SRF funding, well, then the DNR is the lead agency. The DNR was saying, well, we're not really convinced that this is a really good use of SRF money, so we were in limbo there a little bit. And finally, I like to show this when EPA people are around. So they came to the rescue in 2010 when they distributed SRF funding and said, hey, categorically, creek daylighting is a green project. So not only did it open the door for the DNR to, you know, easily say, yeah, okay, we feel comfortable now, but they also allocated $5.9 million of our loan as a forgivable loan. And again, we don't fault DNR at all for that. They take their job very seriously as to how they're going to use SRF funding, EPA funding, and we appreciate that. It was our job to, you know, kind of convince them. And if we were going to, you know, propose something like the LA River, this concrete line channel, well, obviously, that's something they're not going to be interested in helping to fund. But just kind of show real quickly some of the images of the creek restoration. So the lower B branch was completed in 2011. This was a parking lot before and then after. This is just in its infancy. This last summer we had the prairie grasses, you know, assessed by an ecologist. And another example, so it's not just daylighting a project for flood control. Obviously, we're creating habitat as we go. This is what you're looking at here is essentially they're pulling off the top of the old buried storm sewer and just starting to remove it, and then that's the creek area. Now some of you are probably saying, "Wow, how you use that winter photo for the, you know, the before and then this summer." So this is a winter photo, and yes, that's a bald eagle, and we have this on video. You can go to our website. I could play it if we had more time, but you can actually see it swooping down and grabbing a fish and flying off, and it's pretty neat. So, and the DNR did a fish assessment, and yes, lo and behold, we do have fish in the creek. And also redevelopment. So this is what other funding mechanisms that come into play is when you do something like this, we're kind of creating this amenity, this attraction that people will nearby start to embrace and want to be a part of. And so this is a private developer who didn't use any brownfield funds, but essentially was a brownfield redevelopment site. They took it upon themselves to have that redevelopment site. Just kind of moving on to the upper B branch. So one of the things you'll notice here, it's greener in nature. This goes more into our neighborhoods, our residential areas, and so that's why that's different characteristics there. But there's some of our funding partners, and I'll get to those just a little bit. Working with the railroad, fun. But just showing what it looks like. So top is what it was intended to look like, and then the bottom right is what it looked like a couple weeks ago. Showing a vision of the project was extremely important. That's why we had to do those renderings so people would understand. Just going to zoom in real quick. So we have a man-made creek. We recognize that. But one of the things we want to do is how can we, in an urban environment where we're trying to limit property acquisitions, we're trying to, you know, limit its impact on the community, add things. So one of the things we added was fish habitat. One of the people who was walking by the site approached one of the city employees and said, "How come those blocks keep falling in the water there?" So obviously they didn't realize that they're in purpose. And you know, we work with the Department of Natural Resources again. How do we promote fish habitat? So we have these weirs to kind of change the flow dynamics, create some riffles, some turbulence for fish habitat, buried woody structures, scour holes. The wooded area here, I can't see that, on the right side there, is for fish to actually swim underneath the embankment there give them shade, whatever fish like to do in the dark. Then just kind of turning and looking upstream. One of the things you notice, there's there's an amphitheater there right next to a neighborhood school. On the left there is a biofield that's under construction. Any place where there's a local water going in, it's going to go into a biofield, rain garden type structure. This is kind of looking up 22nd Street. We have a spillway there for excess water, so it doesn't rip up the channel every time it storms. This is just kind of looking at the old sewer that replaced. Give you a size of the magnitude of what was there before. Just to kind of go through the cost of all of our improvements, it's over $200 million. So we started this in 2003, and it's going to be, it's going to be my rest of my career, I'm sure. But just show how the money tree kind of shakes out. It all started with use of SRF EPA money. So had we not daylighted the creek, we would not have been able to use the EPA money. And the use of the EPA money opened up all these other doors for us. So by accident, because it was cheaper, we started going down the right path. The other part of it is because we had this daylighting project, it's kind of an amenity, it's an attraction. And so we have Vision Iowa money that's for creating just that in Iowa. So they have about $2.25 million for adding the hike bike trails or adding lighting, just adding little elements to dress it up. And then there's also ones that are related to economic development. And then we have transportation money in there. So the hike bike path that you saw, we have National Scenic Byways money to help build not only the trail but the amphitheater, because while the Federal Highways isn't interested in flood control or flood mitigation, they are interested in alternative forms of transportation. And so they basically worked to help fund that element of our project. And then, of course, the kind of the disaster related part of the project for Iowa Homeland Security Emergency Management. But if we hadn't used EPA SRF money, we would not have been able to receive the funding there. I'm just going to quickly go over two of the funding sources. So of the $210 million, we've got $152 million in state and federal funding for our project. So one of the things was a sponsorship project. So I'm only aware of Iowa and Ohio actually using this, although it's allowed. So we had a treatment plant upgrades planned for our community. And so we had a $64 million loan. To fund that through SRF, we were going to have a $33 million in interest we were to pay off over the course of time. Through this sponsorship project, they actually restructure the loan, decrease the interest you would pay back, and increase the principal. And so this $9.4 million, we actually were able to use to build the first 73 of the 240 alleys. So the community pays back the same amount to the Department of Natural Resources, but we get more for it. The other one I wanted to point out is the state's flood mitigation program, which is probably the only one like it's in the country. Essentially, it kind of came out of the 2008 floods that Cedar Rapids experienced. How it works is, so the state has sales tax of 7% usually. 5.5% of that goes to the state. So when someone buys $1 worth of something in Dubuque, Iowa, 5.5% of that you get taxed on, it goes to the state. Well, say that 2013 was our base year. At some future year, that will grow. You're going to collect more sales tax just because of inflation or what have you, more development. And basically that's an increment over the years. And so they basically said that you could use up to 70% of that locally, basically retain the money locally to work on flood mitigation projects. And that's paid out over 20 years. So one of the, again, if we hadn't used EPA money, we would not have been eligible to even apply for that, those funding. But some of the things they did include in their requirements when you apply is it had to be watershed-based approach. It had to consider upstream, downstream impacts, conformance with the comprehensive plan, et cetera. So, and there's the federal funding. We needed federal funding in order to get that money. So you see that out of the $210 million, the city shares about $57 million, which is still $1,000 for every man, woman, and child in Dubuque. We do have a stormwater utility in Dubuque. It's the second highest in Iowa, only behind Des Moines, the capital. It's about $6 to $7. It's $6.81 right now per SFU. We generate about $4 million a year on our stormwater utility. So, is that any questions?
Very good. The B branch is coming back to life. Who's got a question here? Anybody?
Hi, Darren. I'm Steve Hopkins, Nonpoint Source Coordinator from Iowa DNR. Several years ago, we featured the B branch daylighting in our annual Nonpoint Source Watershed Success Story publication. I think we'd like to do an update on that.
Darren, how did you find out about the SRF funding the interest rate break? We've tried to get that out to, municipalities and that kind of stuff. I mean, how did you find out about it? Did SRF did DNR tell you about it, or how did you figure that out?
Well, one of the things that I didn't mention, and kind of what's happening was, so we had all these improvements that we're going to do, and there was not much money for stormwater flood control. And it was just coming about where they were starting to spend SRF money on stormwater projects. And the Iowa Department of Natural Resources under Patty Cale-Finnegan just does a phenomenal job of trying to get the message out that we have money for these types of projects. So it's really, they have just a robust public information, get the word out effort. Essentially, we were looking at it because at the time the interest rates were fluctuating so wildly, and the nice thing about SRF is you know what the interest rate is going to be. So you can program that over 20 years. You can set your stormwater utility rate structure because you know what the interest rate is going to be. So that was kind of why we looked at it. And they just, over the course of like 10 years, we've gone from zero money for stormwater to now it's really starting to recognize the mutual benefit of stormwater management.
Here, Darren. Have you quantified your flooding prevention benefits of this project? I mean, and how do you communicate that? I mean, you mentioned like a 7-year storm, or for one. But I mean, have you quantified it, and how do you communicate what the flooding benefits is of what you've done?
So that's a great question because it's a struggle for us. It's a multi-phase project. One of the things I didn't show is this creek project, the full flood control benefits, we still need to go through the railroad tracks. And so we hope to do that in the next 2 years. We're actually tunneling culverts under the railroad tracks to try to minimize their impact. But, for example, one of the things that we did recently, we give presentations all the time to the citizens and the council and updates. So we have cameras that would show how deep the water was in the creek. And we just show them, hey, if we have our culverts in place, that's 5 feet lower. We just have to anecdotally say things like that because that's always a challenge as to how do you, convey. I mean, modeling is the main way. We have a computer model that predicts what our benefit's going to be, and that's kind of what we have to rely on. Just because with every improvement you have incremental benefits, but, it's hard to tell. And of course, for brainstorms differently. It's hard to tell them, well, without spending money and hiring engineers to look at it to tell them exactly what the difference is. Most people just say, hey, in 1999, I had 6 feet of water in my basement. 2011, I only had a foot. So.
Progress.
You mentioned, the 3 large floods, 3 large precipitation events in the real recent history. What design flows did you use? Because I mean, if you're seeing it going up, are you using what models, what tools are you using for design flows, or did you use the historical record?
So our watershed is very flashy in nature, so we designed for the 2-hour 100-year storm. That's kind of what our design elements are. But we actually have like 3 to 4 feet of freeboard in there because we're actually going under the railroad and they have their own requirements. But that's essentially what we're designing for. So it's we're following either Huff and Engel's, Bolton 71 of precipitation, analysis or frequencies, and then also NOAA's latest, bulletin. So that's kind of what we're following. It's a 2-hour, 100-year storm.
All right. Thank you again, Darren. That was very good. Next up, we have Rich Clater, who I hadn't seen for a while, and he's going to be presenting on green infrastructure case studies in New England. And let's see if we have you. Do you see yourself? There you are. Right there. Clater. Put my name on it. Okay. There you go. You got a remote right here.
Thank you, Barry. Thank you all for inviting me. I'm the president of the Horsley Witten Group. We're a environmental consulting firm. I'm located on Cape Cod here in Massachusetts. I washed ashore on Cape Cod 15 years ago. That's what they call you there. Unless you were born there, then you can be something else. But I washed ashore from the Mid-Atlantic and about 15 years ago, as I said. And when I came up from the Mid-Atlantic, I had been weaned on innovative stormwater, I guess, in the Mid-Atlantic. I worked for the Center for Watershed Protection. We were doing all kinds of sort of Chesapeake Bay protection and restoration stuff. And 15 years ago, I got to New England, and our firm wasn't doing much green infrastructure or low-impact development. And New England, I would say, was a little behind the curve. And so over the last 15 years, we've been we dove right into green infrastructure and to low-impact development, and borrowed lessons learned from elsewhere, and certainly have learned a lot of lessons along the way. So what I thought I'd try to do for you today is just give you a quick overview of maybe what those last 15 years have been like, and I say in this slide some of the major components of green infrastructure implementation are listed, and I don't say all of them. I'm just trying to get a sense of what we're doing here. But, it all does start with watershed planning and assessment in terms of implementation. Are you putting enough of these controls in the right places? Are you managing for the pollutants of concern? Do you get good coverage? And I'll talk just a tad about that. And then I'm going to talk a little bit about how we identify sites for green infrastructure, because if you're going to implement something, I guess you have to start with a location. You've heard a little bit from the last speaker about how you pay for some of this stuff through innovative programs or through state revolving loan funds or, a combination of sources. And then there's the whole design, construction, and maintenance topic. It's clearly part of implementation. And acceptance. Ultimately, for us to have these facilities in the ground and have them functioning, they have to be accepted by a wide audience, the owners, the general public, and really everybody else. And then lastly, implementation is also about performance. Do they work? So I'll just talk about 3 of those big picture comments in the next 20 minutes or so. You could spend the whole conference on just performance of green infrastructure and how well they work or don't work. But let's talk a little bit about how you identify sites and pick them and figure out what you're going to do in a watershed. We'll skip the watershed planning part for now, and then we'll talk a little bit about some lessons learned in the design stages, and then ultimately the construction of these facilities. And then I'll share with you a little bit of a few case studies from here in New England that I think get to this topic of acceptance and ultimately widespread green infrastructure. So identifying sites, and then you've heard this in prior speakers talking about retrofitting existing impervious cover or whatnot. It begins with good mapping and good tools, and then a rapid verification of whether or not sites are feasible or not, and then choosing the preferred practices. So the 2 pictures, the two pictures here, just, you know, a field crew out in the field looking at a possible candidate site and doing some data collection, and then a sketch that will ultimately get into an assessment report on how this facility might look and where it might go, really, and what you're going to propose, in this case of a bioswale in the slide. So a good case study up in Burlington and South Burlington, Vermont is the Centennial Brook watershed. In the Burlington area, there are several communities that have impaired water bodies in urbanized areas, and so they're required to do flow restoration plans and essentially identify lots of sites. So in Centennial Brook here on the slide, all these different colors are really the retrofit sites that have been identified, and there are 50 different candidate sites. Some of them are existing detention ponds, some of them are new facilities, and ultimately 90% of the impervious cover had to be managed in this watershed to ultimately meet a flow objective and to comply with the requirements of this flow restoration plan. And the bright yellow are drainage areas to existing detention basins, and then the faded area is new facilities. And I guess what it tells you, at least in terms of a system like this, is you're going to need a lot of implementation. There were like 48 sites that needed to be developed there. And the way we do this in the field is essentially to use the latest technologies. We've come a long way in being able to rapidly identify candidate sites and using tablet computers basically and GPS-based controls to be able to go out to a site, identify the constraints, bring up on your tablet the utilities and the soils and the other parameters that might that we would have had to have all kinds of paper maps just a few years ago. You can identify the sites, you can load them up remotely, you can report out to your client or to a stakeholder group right away, and then you can create all these customized forms now that of the data you're trying to collect. So we've got really great tools in terms of being able to you know, define it, what we're looking for green infrastructure, and define the constraints along the way, and ultimately spit this out into a report. This little form on the left is a direct output from a tablet computer that then can be uploaded and sent off to a client or a homeowners group or an interested party that wants to know about it. And so it's very nice. It's all Google Maps now, and so you can share those links with a bunch of people. And so the whole identification of sites has gotten to be something we can do very rapidly, and now we can do watershed scale planning in a day or two with a good crew and the technology. And so just a wonderful change in my career over the past 3 or 4 years, 5 years, in terms of being able to ultimately collect this information. So in terms of design and construction over the last 15 years, you know, what have we learned? Well, we've I guess I'll just go through a couple of the examples and see if you get a flavor for that. What I tried to do here in this slide is list the most prevalent, the pressing design issues that we've seen in terms of green infrastructure success. And you might not think the depth of a facility is a big design issue, but it's a huge driver in terms of successful green infrastructure and successful projects. Things like curbing and fencing, and maybe a better way of putting it is public safety. I mean, we're taking the infrastructure that used to be underground or used to be a detention structure behind some you know, retail center in the back of a parking lot, and we're bringing it out into the parking lots, we're bringing them out into the streets, and we're we're also interfacing with the public, and we're introducing a lot of different things that we didn't have in the past. So little things like tripping over curbs of green infrastructure or falling into something that's too deep are clearly implementation issues that we didn't deal with perhaps in other controls. But sediment management, this gets into the maintenance. It was discussed in the first speaker that Steve talked about. These things go on the ground, and then the next thing you know, you have an upstream construction site, and it comes in and causes problems. So a real important component of these designs. The inlet options, lots of green infrastructure controls have been built where no stormwater gets to them because the inlet doesn't work terribly well. So miscalculation of drainage areas and velocities. A critical component is to sort of make sure that you get your microhydrology right and make sure that you contemplate the potential impacts. So that's a big one. Underestimating the maintenance burden is a critical thing. The first thing you have to do with any kind of green infrastructure is understand the owner and then their ability to maintain the facility, both in terms of budget, but equally important is equipment and personnel training. And these practices are very different than many maintenance crews are familiar with. And so understanding that is a critical component ultimately to implementation. We've seen a lot of advancement in new approaches, and we've applied them. I'll show you a few photos of those as we go along. Those often are not vetted before they go in widespread implementation. And you just have to be very careful. This field is moving very fast, maybe not as fast as the auto industry and self-driving vehicles and whatnot, but we're certainly moving at a fast rate, and we're putting in a lot of green infrastructure for combined sewer overflows, for other water quality work, and we have to do a good job of vetting these different approaches. And then overplanting or landscaping in general, we want green infrastructure to look great the day it's put in the ground, and then we take all those photos the next day, and then we go away, and then we come back in 5 years and we're like, whoa, we've got a jungle on our hands or something else. And it's a critical component about the aesthetics, and this ultimately leads to the acceptance. And there's a slew of construction-related issues. You don't think of construction as a design issue, but we have to understand how to build them and account for that in the design plans. We could, again, spend a ton of time in here. So let me just go through a few of these. I don't have a lot of time to dig into all the details, but on the upper side is an early design of a bioswale, and it's probably about 3.5 feet deep and has steep side slopes and erodible soils, and aesthetically isn't the greatest looking thing. And just a simple design change to say, look, we're not going to have these bioswales any greater than about 9 inches, or 6 inches is even better, makes all the difference in the world. So understanding the aesthetic of the practice as you design it, and there are reasons things get deep. They get deep because of the terrain. It might be steep. You might have a design criteria. We're trying to do a bigger storm. Hopefully not the 100-year, 2-hour storm, but in some cases you are trying to do bigger storms, and so that pushes the design. So you have to be very careful with all of those things. The whole issue with sediment management, we've come sort of a long way. I think the short answer to sediment management is have a defined location where the sediment can drop out easily and can be cleaned out. Perhaps that picture in the upper center is maybe the best. It has a brick paver area around an inflow location, and sediment will drop out there, and it could be scooped out pretty easily. And so that's sort of the key. If you're gonna try and capture sediment and expand the design life of these, and not get the rest of the facility contaminated, and put in a place where it can get cleaned out easily. tree filter pits. This is like a whole topic in its own right. We're using more and more green infrastructure. Tree filter pit is essentially vegetation in a confined system, which was generally underground, and can be a real nuisance, let's say, in terms of making sure the thing works. Ultimately, I'll show you an innovation of that in a moment. Right-of-way bioswales. This is some photos from New York City, who has embraced the green infrastructure and the right-of-way bioswales throughout their public rights-of-way. And many of these systems have been evolving until they settled on a uniform approach. One of the key things with this is understanding how well they're going to perform over the long term, and are they maintainable. The facilities have an inflow and an outflow and very little pretreatment or sediment component, and we've got to make sure that they can be maintained. Just a word on vegetation. On the left-hand side is a bioswale shortly after it was planted, and then just 3.5 years later, or 4 years later, the vegetation can really take over. So while it's probably okay function-wise, from an aesthetic standpoint, it's clearly a changed environment. And I think if it was designed to be a very rustic-looking component, it probably would be fine. So it's the setting that you do this and understanding the owner's ability to maintain it. I show this one by comparison, a cul-de-sac on the left-hand side right after it was designed with almost no vegetation, just a couple of trees and shrubs, and then a decade later, and the trees have grown up, and it's very sparsely or growing up. And then you have a homeowner who actually lives on this cul-de-sac who maintains it. So they've sort of taken ownership of a public infrastructure. So it's a key component here. Construction, just a caution that green infrastructure controls are particularly susceptible to screw-ups during construction. And, everything from the staging to the management of sediment during construction to compaction and the wrong soils and all kinds of different things that can happen. This is a bioretention facility that was put in too early and, had a big storm event, and you wouldn't be surprised that the soils don't infiltrate terribly well. So we've seen a lot of evolution, too, in the designs. We're integrating the function of bioretention or the function of green infrastructure with landscape architecture, and you're getting the aesthetic component moving forward. This swale system in California, for example, this isn't a local example, obviously, but a really cool way of handling the sediment and the velocities in the inflow. This is a tree filter pit that has pre-treatment built into the catch basin system, and it drains subsurface, and when you're walking along the street, you don't even know that this is a stormwater facility. It's been incorporated into the design. The bioswale, for example, New York City's approach can be enhanced by increased storage, by putting in chambers underneath the system or additional stone and finding a place for pretreatment. So all of these practices have the ability to be modified. Let me skip over this little case study, and I want to go into this one here. And I'll just hit these two in my remaining 5 minutes or so. Roger Williams Park is in Providence. It's probably the signature park of Providence. It's a 475-acre urban greenway built in the 1870s and designed by Horace Cleveland. Very much a classic urban park of the era, and featuring lots of waterways. Over 100 acres of those 400 acres are ponds. And upstream from this park is another 600 or 800 acres of urban area, and these ponds have been significantly impacted from water quality. So as part of a water quality management plan, we put in a bunch of green infrastructure controls throughout the park. We identified them, cited them, and then ultimately designed them. And so this is the sort of design sketch using the technology and it incorporated in the planning process, and then rank them. And then just we've done 6 or 7 installations there, pretty dramatic projects, but I'm just going to feature a couple of them here. The first one is this double boulevard that was built and expanded in the 30s as part of the WPA, I think. And you can see just the sort of horrible condition of the road and just the maintenance burden of all this impervious cover. So what we ultimately did was did a pavement reduction component, so as part of green infrastructure trying to get rid of the impervious cover, a buffer restoration, and then ultimately a stormwater treatment. And it really is dramatic. Where basically it was an underutilized road, so it didn't need to be travelway. You take that out, you incorporate a buffer enhancement, and then the stormwater treatment in a swale system. And to just undo the geese habitat on its own part, I mean, when we're talking about implementation, we're trying to think about all of the components moving forward. Pavement reduction here, buffer restoration, stormwater pretreatment. So again, a pretty dramatic component of sort of building in these different elements of green infrastructure control. The next site was a wet swale, and again, here's the schematic component, and then a little before shot. This again was another favored geese feeding area, and then what we proposed, including the stormwater pretreatment and the buffer restoration, and this is a wet system right at the edge of the pond system. And then the last case study I want to feature is some work ongoing with the Boston Water and Sewer and the public school system in Boston, where they have a major initiative to basically comply with some EPA consent agreements and treat stormwater and manage combined sewers. But they're starting with these 5 public schools, and the major component that I think is most exciting is essentially curriculum development for the schools, and the project is to implement green infrastructure at 5 public schools to address water quality, but probably the more important part of it is to educate the students, and so the designs are interactive with the curriculum. The 5th and 7th grade curriculum in the science department is being set up to allow the kids to go out to the outdoor classroom and then to test various components. The sites are multifunctional green infrastructure design. They're swales, they're channels. The upper right hand is a play field using a permeable turf, and then channel components. And the first school is under construction right now. Let me skip ahead to the proposal. It includes porous surface and bioswales, underground chambers, and then an outdoor rain garden classroom. In the front of the slide, what is sort of cool about it is that it's a paired watershed. On the left-hand side, there's a parking lot that drains to a concrete swale, And then on the right-hand side, the same size parking lot drains to a bioswale or bioretention facility. And so all the gauging and other information is being incorporated into the curriculum. And so students will be able to go out there and look at the difference between kind of gray infrastructure and green infrastructure. And I think that's probably the most important, hopefully, lesson that we're going to learn. Just a couple of construction slides that we're finishing this month that are going in. So let me conclude with just a couple of challenges, and this is sort of my punch list of things. Select the appropriate practice makes a big difference. Design with nature in mind, aesthetics, surrounding conditions, and then this sort of concept of addressing the maintenance burden. You've got to do a lot of boring stuff that we don't have to go over today, but we really have to dig into the weeds in green infrastructure to get it right, using appropriate tests and surveys and understanding budgets and ultimately, again, the maintenance and the proper criteria. And then construction components are critical, starting with a good set of design plans, contractor expertise. You'd be amazed how many of these projects are publicly bid projects and often go to the lowest qualified bidder. And so making sure that you have qualifications in a bid package are pretty critical to getting a good project out of it. And some of those other things. So I'll conclude with this, just a simple message of a formula for sort of long-term success that, you know, they're visible, they're simple, easily understood, lovable. You know, these things become one. I think somebody mentioned that the local people are actually maintaining it, then, you know, then it's going to happen. And that's what we're looking for, and I think that's what we hope to achieve here.
All right, sort of like people too, visible, simple, easily understood, lovable, we maintain. Thank you. That was, a whole lot of experience, broad and deep, you know, a month's worth of lessons learned in there at least. Who wants to go first? I think you've stunned them into silence here with...
Yeah, it's the break. I'm standing between them and their break.
As usual, no break for me. No, I actually have a question for everybody here, at least the ones from the northern tier states. Green infrastructure, getting the water into the ground, is the best way to go, except in a few instances that we have in Maine. And that's where we have first-order urban streams that are largely, that have commercial development in the watershed and or interstate exchanges, where they have real heavy use of de-icing salts. And what's happening in these watersheds is the salty water during melt events is getting into the groundwater, and it's contaminated the base flow in the stream, so the streams are toxic year-round. And we have aquatic life impairments that this is the most likely cause of it. So if you're doing retrofits in these watersheds or new development in the watersheds, it's kind of like the last thing you want to do is have year-round green infrastructure. And I wonder if anybody else is figuring out ways to deal with this. You know, one thing is if you can make your system so it can be offline during the winter and directly discharges to your stream so you can get rid of that salty water quick and let it get out of the system quick and have less exposure. But, you know, then somebody has to turn the switch on the BMP, whatever, and that's a little tricky. But I was wondering during the break if anybody is experiencing this same thing and trying to deal with it. I'd love to talk to them about it. And Rich, do you have any comments on that?
Well, I mean, the point is is well taken. I mean, if we're applying tons of salt on our winter roads and then we're infiltrating that directly into groundwater, particularly in small headwater streams, you have a potential problem. I think the key is to understand the application of these things. If you can reduce runoff from rooftops and from non-saltable areas, areas that aren't getting vehicular traffic, go for it. I mean, get as much as you can out of that. Keep the runoff from going onto the road surfaces in the first place, so you don't have a bigger volume that you have to deal with. And then if you have a particularly sensitive stream system that, salt is going to cause a problem, you have to do something different than just like porous pavement or swales. You're going to have to think outside the box, I think. I mean, it's one very specific problem but it's fairly universal. I mean, you've got an awful lot of area that's being salted. So, I mean, we could use less salt on the roads. That would be maybe your starting point.
Another question before we go. Okay.
Can you talk about the drivers for this green development? I mean, it is expensive.
So drivers, well, lots of drivers. Probably starting with ordinances and bylaws that are runoff reduction oriented in terms of they're looking not just at a water quality target, they're looking at a total runoff reduction component to help with pollutants and to help with channel protection, erosion, and even some flooding. So you see a lot of that in the ordinances. We are seeing more of the drivers in some of the property values and some of the aesthetic appeal of this, that you're getting developers and ultimately the people that are living and shopping in these places are starting to embrace it. So it's reached a certain threshold. Combined sewer overflows and consent decrees in a lot of the cities in New York City, Boston here with the public schools, Philadelphia, elsewhere, a lot driven by trying to get away from just gray infrastructure solutions, just tanks and tunnels and that kind of thing, and trying to bring these things to the surface, and then also the public awareness and the jobs of constructing them. You're getting a lot of that in sort of a green economy. So there are a bunch of drivers. Probably starts with the regulations or ordinances the first. I'm sure there are other drivers that people would mention.
All right. Well, we got one more?
Yeah.
Where are they?
That's it.
Oh, that's it. Okay. Rich is calling this to adjournment. Thank you, Richard from Horsley Witten Group. All right, I do have a couple of announcements here real quick. During this break, Minshew, Bob Day from Michigan, Paul Thomas, and Carla McCulloch, the speakers for tomorrow morning's session, will meet up here about 3:15 during this break. Also, after the session is over this afternoon, at the end of the day, Brad Lamb wants to meet with all the Region 6 folks in the back foyer there after we get done with the lightning round at the end of the day today. And then finally, if you want to do the historical tour tonight during the event, during the social event, you need to sign up at the registration table. Back here at 3:30, we got some high energy music for the lightning round. We are going to spend the first hour listening to each of a lot of presentations, and they're going to go very quickly. The speakers will be standing up at their place for the first hour and give a very short presentation on their topic. After that, we'll spend the last 30 minutes interacting with the speakers and their presentations in different places, and I'll tell you about that in just a second. Some of the interaction will be around a poster. Some will be presented on computers. 6 of the presenters will be set up down the hall here in the Wheatley Terrace room. 2 will be set up in the foyer in the back of this room, and the rest will be in this room. We encourage everybody to get up and walk around after this hour of lightning round presentations to interact with the speakers individually. After this session, after we hear the presentations for an hour, interact with the speakers for a half an hour, we will not reconvene. You'll go straight to wherever you're going to go, but join us at 5:30 for the social event on the mezzanine level, formerly known as the second floor, now known as the mezzanine level. In the press room, there'll be a cash bar, and the hotel history tour will take off from there. So, without further ado, we're going to start on these. I'm going to ask each speaker, when I call your name, to raise your hand so we can get the microphone to you pretty quick. But again, the speakers will stand up in place, give their presentation, and we'll move to the next one really quick, because we do have quite a list of them here. So first up, we have the Minnesota Buffer Initiative Project, Justin Watkins, Minnesota Pollution Control Agency. Are you ready?
Good to make everybody turn around, or should I? No, you're good. Okay, thanks. So, again, Justin Watkins is my name. I work for the Minnesota Pollution Control Agency, an entity that is in charge of the 319 program in our state of Minnesota. We actually have 5 agencies in our state that deal with water, and I'll come back to that at the very end to close. But so the program says Minnesota Buffer Initiative, and I think it's a good thing to come and share with a national audience here. I don't know if I'd call it an innovative tool, but it's a good kind of a initiative to push forward and use a tool that's been in place for a while. So, so to that end, I've brought a display and a bunch of materials and some good summary information to set up in the other room here. Detail about it after this, but I spent a little time trying to distill it into. I didn't quite get to 10. You've seen some of those lists of 10, but I got 7 key points that I can share in probably about 3 minutes. So the first one, the program could say Governor Mark Dayton's Buffer Initiative. And I don't know if any of you are familiar with our governor. He's a great leader in our state. Maybe you've seen him in national headlines. He inherited a giant deficit. He turned it around to a surplus while adding 200,000 jobs, and he's reduced unemployment. I just mentioned that for context because he's had a very successful. When he ran in for his second term, I think the Republicans marched somebody out, and I don't even know if anybody remembers his name. There wasn't a negative thing to say about him, about Governor Mark Dayton. So, but the other part of that is he also has an eye to water quality. So to the point here, this truly is the governor's buffer initiative. And when I tried to press a little bit and ask some people who are closer to the political workings than I am, how did this, because I figured some people here might like to know, what was the genesis of this? Who were the people that actually talked through this? And, you know, I'm sure there were many discussions, but here's a quote from him, the buffer coordinator. He said, "Few, if any, people knew it was coming when it was originally proposed." So that translates to, again, the governor got this going. So good, strong political leadership there. I think he sees it as, he brought it up at a Pheasants Forever meeting. I think he sees it as what's one thing that we could do to just lock down and get done in our state. So credit to him. And then the second point is not new, as many of you probably have. We've had for decades a shoreline ordinance in our state that requires a 50-foot riparian buffer. All the counties except one have adopted it. So it's not a new rule. Just like to clarify that because it was kind of being in some ways described as such. But it's an initiative to implement the rule. So I got 3 points here that kind of describe how that initiative does that. First, it creates a uniform statewide understanding of what waters require buffers. That sounds like maybe a simple thing, but it's nice. Every county can now go to the same map and look at in very good clarity which streams require buffers in our state. The second one is it provides enforcement. Now, each county wielded the ordinance differently in our state. I think there are about 80 counties. This installs an administrative penalty and says if you don't, if the watershed district of the county does not implement this, the state can impose a penalty. So that's a second big piece of it. It provides uniform enforcement. third big piece is it sets timelines. So by about this time next year, the streams will be buffered, and then by similar time in 2018, all the ditches will be buffered. There's a little more detail, but I'm trying to sum it up here. And the last thing I say is, you know, just checking in with our buffer coordinator, who's pretty well tuned in. I kind of asked him, just sum this up for me. How are people receiving this? What are you hearing? How are you working through this? And he said, the summary is that it will be successful. He said by this time, a couple years from now, we're going to have of the streams that aren't buffered, 90-some% of those will be buffered. So we'll have nearly everything. And the reasons it will be successful are, first of all, it provides a little flexibility. It's not rigid where it just says, this is the absolute 50-foot buffer on every single stream mile without exception. It's a 30-foot minimum, a 50-foot average, and it also, in some cases, will allow for alternative practices if you can make a case and show that the alternative practice will have equivalent water quality benefit. So that flexibility, I think, is a part of the success. And then it also provides resources. The state has developed a buffer tracking tool that can be used by the local government units. They can log in and access it. And it takes the place of the cumbersome reporting that everybody hates. If they can go through and use this tracking tool and kind of day by day say, we're good here, we're good here, we're good here, and also provides money. Gives everybody money to help pay for capacity to implement. So last thing I'll say is, interestingly, our agency is not in charge of this at all. It's the Board of Water and Soil Resources and the Department of Natural Resources. So again, just to be clear about that, we're the non-point source entity, but we don't have any enforcement in terms of this initiative or rule.
All right, Justin Watkins, MPCA. He will be in the Wheatley Terrace. Next, we have Mark Voorhees, Region 1, and on deck, Sean Chado. Where's Sean? Just so we can get, okay, Mark, you go ahead, and we'll have Sean getting the microphone set up. Go ahead.
Hi, I'm Mark Voorhees, and I'm going to talk about the Stormwater Management Opti tool and give you a quick overview of that. We do have a poster over in the far room, and also a fact sheet in there, a two-pager that will help describe what it is. So this tool is a tool for developing stormwater management plans to address primarily nutrient loading, sediment loading, also has trace metals and hydrologic imbalances. Its genesis is the stormwater permitting program in Region 1, and followed up on the Charles River TMDL done in 2007. Over the last 10 years, we've been working on various permit aspects and recognize the importance of having a comprehensive tool that would allow for very comprehensive stormwater management planning using consistent accounting and performance methodologies. So the tool is it's an Excel-based tool, although it does run in two modes, a planning level mode that runs in the Excel framework, and then also uses the sustain model, so it can run in a continuous modeling simulation using sustain. The tool comes with calibrated time series of flow and nutrient quality hourly time series based on regional precipitation data, based on swim modeling, actually. And it's calibrated for performance, so that the sustain portion of the model is calibrated to University of New Hampshire's performance data. So the calibrations and the values in the tool are consistent with the accounting methodology that we have in our recently finalized Mass MS4 permit, which requires implementation of many phosphorus TMDLs, the Charles River plus many, many lakes phosphorus TMDLs. So the tool is originally designed to support the permitting program and to give the permittees the ability to develop more technically and economically feasible plans. It estimates performances, cumulative long-term performances for 11 categories of structural stormwater controls, as well as varying design capacities from very small to very large. So you're looking at some of those green infrastructure incorporated into residential areas. It's also been designed to be very flexible and adaptable to other locations where you could generate time series range based on local climate data, cost data, and so forth. So the intent is for it to be a tool that's available region-wide and can be readily applied in other places and using local specific data. And that's about it.
All right, and Mark, and will you be in here or in the Wheatley room? The other room. Wheatley Terrace. Okay, thank you, Mark. Next up, Sean Chalo, Santa Clara Pueblo, working remotely alternative approaches for hard-to-reach stream work.
Good afternoon. My name is Sean Chato. I'm from the Pueblo of Santa Clara. I work for the Office of Environmental Affairs. Our department is both funded through EPA funds, the 319 as well as the 106. And currently we are knee-deep in restoration efforts. We had a major forest fire back in 2011. At that time, it was the largest in New Mexico's history at a little over 156,000 acres. Of that, it burned a little over 17,000 on the reservation. So we've been using those 319 efforts, our funds, to help in our restoration with various sediment control structures and flood mitigation. We focus more of our projects up in the upper watershed, and we also work with various federal agencies, U.S. Army Corps of Engineers, FEMA, NRCS. They've all been assisting us with our restoration efforts. So I don't want to give too much of my presentation away, so that way you'll come and see me. So,
all right, Sean Cato, Pueblo, Santa Clara, thank you very much. And next has Fred Suffian got a story for you.
So we had a work group that put together the National Highlights Report that you've heard about yesterday by Linda, and several of us had ideas of what if we take that a step further. The intention is to put the National Highlights Report on the web, but as you saw, as many of you seen the report, there's spaces of success, and those spaces of success are your success stories. So I think there's 8 or 11 8 faces of success. So we've had a chance to put together basically 4 story maps. And so I've worked with 4 of the states, Steve Sari from D.C., Watts Branch, Sam Marshall is here from Tennessee on Crab Orchard, and Teresa Kuhn is here from West Virginia for Sovereign Run, and Bob Day is here from Michigan, and it's Thornapple. So we're going to be in the back of this room here. We've got 4 laptops set up, story maps on each. I'll be there if anyone has some questions about the guts that are running it, and these folks will be there for the technical content and any other questions you might have about the stories. So that's what you'll see. Come on back.
All right, thank you, Fred. And where's Craig Lott, who's on deck? Okay, very good. All right, Craig Lott, you're up.
All right. Hey, I'm Craig Lott from the Department of Environmental Quality in Virginia, and we, every 2 years, are responsible for reporting the Nonpoint source assessment to EPA, and as a part of that chapter that we develop every 2 years, we, in 2002, began modeling statewide at a pretty coarse resolution our GWLF for non-point source nitrogen, phosphorus, and sediment pollution going into our watersheds, around 500 different subsheds in the state. Since then, we've upgraded the model once in 2006 and this year in 2016. And I have a poster back here in the middle of Fred's computer bank. So if you want to come to the back of the room, I'll be back there and tell you a little bit about our tool, our upgrade to that. We're now at 1,239 watersheds. And we've also added additional land use layers, incorporated in-stream sediment erosion as one of the components for modeling each of these subsheds. And we're using that to help prioritize our projects and in the future be able to have better decision-making about our loads and what the sources are to those loads and how best to manage and put in BMPs and where to do that.
All right, Craig Lott, Virginia DEQ. And did Fred have something to add here?
Yeah, one other, we actually had a fifth story, Paul Emmer from Maryland, and he put together a broader success story that you'll see. He has a story map right back there along with ours as well on Maryland's success stories.
All right, now up is Adam Jorge, the grits guru.
Hey there, Adam George. I work at EPA headquarters. You can call me Jorge, though. That's great. I work at EPA headquarters for the Nonpoint Source Program. I am the grits guy. Just in case anyone was just curious, how many of you know what grits is? Oh, that's a good show of hands. Very nice. Okay, now how many of you personally use it? Okay, great. Now here's the fun question. How many of you love it? You don't have to you don't worry about hurting my feelings. How many of you love grits? All right, I see a couple. So, my job, the way I feel my job is that I'm trying to bridge the gap between those two sets of hands. So I personally love data. I love getting into these projects. I learn a lot from it. There's many different requests for grits data. Sometimes it doesn't make it down to the states. Not everyone is sure how we use data. In the last couple of years, we have tried to compile user feedback, things like this is really hard, I don't really like doing this, or this field's always blank. And we've also gotten feedback from people who use the data, want to use the data, want to apply it in new ways. So we've put that together. We've spat out a new series of changes. I personally think they're great. They're simple. They move things along really quickly. And if you're interested, and if you use it, and if you want to love grits, then come look at me at the session over here. I'll be giving a little power training. So, and just for fun, it's mobile friendly. That's just my own personal.
All right. Thank you, Adam. When I get back to Kentucky, I'm going to tell everybody that somebody stood up at the meeting and said, how many of you know what grits is? Of course, it's supposed to be grits are, but, you know, that's okay. All right, next up, we have Ari Engelberg from headquarters, Adventures in Water Quality Analysis, Integrated Reports, StreamCat, and 319, oh my.
Hi, everyone. My name is Ari. I'm an ORAS with the EPA headquarters. My presentation is going to be on an interactive mapping application, which is looking at grits data. Grits data, the grits geospatial data, 305B integrated report data, and StreamCat data, which is an EPA ORD, or EPA Office of Research and Development data set of various landscape attributes at multiple spatial scales, both the catchment scale and also the watershed scale. So I'm going to be presenting an interactive mapping application for users to interact with and engage with those various data sets. This is a continuation of earlier preliminary research which I had conducted examining, which was the correlative analysis on delistings, to examine various landscape and programmatic attributes that were correlated to water quality delistings. And I'll have a printout of some of that earlier research as well. So I'll be back there just next to Adam if you guys want to come over and see some of what I've done.
All right, thanks, Ari. Next we have Dwayne Young, sharing and discovering water quality monitoring data on the Water Quality Portal.
So if you've ever asked yourself the question, is there any monitoring data around my project or in my area, or who else has collected data? I know you have, Natalie. You always ask that question. So if you ever ask that question, the Water Quality Portal is a great source for that. Over 300 million water quality results are in the Water Quality Portal. That's a huge increase from where we've been in the past. When we released WQX a little over 10 years ago, we were at about 30 million water quality results, and we were super stoked about that amount. And here we are in 2016, and we're at 300 million, which is awesome. However, that's still not enough. So if you want to come over and see how to get access to all this data, we're also starting to focus on other aspects of the Water Quality Portal. So we think we've done an okay job of getting the word out there on how to get data into the portal. If you want to know how to do that, you can come talk to me. I can talk to you about that as well. But we also can talk about some of the new things that we're doing, which is about how to make that data more usable, which includes making use of something called a web service. So if you want to geek out and find out what a web service is, come see me. I'll tell you about what it is and why that matters. But what that means is that you can use data from the Water Quality Portal in tools like R. We've got an R-based tool that allows you to import the data, analyze it, visualize it, discover what else is going on in that watershed or around you. We've got tools that are built in Excel that are directly connect to the water quality portal data, can download the data, do analysis in Excel. Don't even really need to know that it goes to Excel. We're also doing stuff with data QA as well. We found that although there's a lot of data in the water quality portal, not all of it's usable. And most of that is a consistency issue. People report nutrients in many, many, many different ways. And so we've been having a lot of discussion about how to make that more consistent. If you want to talk about that, if you're interested in that, come chat with me. I can tell you what we've learned a little bit so far. Biological data has also been a big focus of ours recently. There's not a lot of that kind of data in the portal. If you're collecting biological data and are interested in publishing that in the portal, come see me. Sensors. We've never been able to deal with sensors very well. If you want to come see what some of our new ideas are on water quality sensors and how to share water quality sensor data, I've got a tool that can demonstrate how that works now and some of the things that we're thinking about there. I can show you that. So come see me if you want to learn about sensors. And then last but certainly not least, if you've ever asked the question, what's upstream of this point or what's downstream of this point, come see me. That's a new capability that we've just released. You can click on a point, a monitoring station, go upstream the entire watershed, and get all the other monitoring stations that are upstream of you or downstream of you. Very cool stuff. So come see me. I'll be over there in the corner room on the other side, willing to talk about anything water quality monitoring data related.
All right. Thanks, Dwayne. And just to remind you, Dwayne, Ari, and Adam will all be there in the Wheatley Terrace room around the corner with all the windows and so forth. Next, we have Carrie Jacobson.
Hadeen. It's actually Kari.
I'm glad I paused. Kari, okay. Pulling the plug, using a river flow model to manage water level on a wild rice lake on the Fond du Lac Reservation.
Yeah, hi, I'm Kari. I work for the Fond du Lac Band of Lake Superior, Chippewa. It's on the western tip of Lake Superior in northern Minnesota. And the tool I'll be demonstrating is the two-dimensional RAS mapper. If any of you are familiar with that, it's kind of the newest version of it. It's part of the HEC-RAS hydraulic modeling software developed by the Army Corps. And the reason it's fun is because it's, like I said, it's a two-dimensional mapper where you can take your hydraulic flow modeling and put it in a two-dimensional map so you can show like inundation, where the inundation is, direction and rate of flow, and then you can animate it. So there's kind of like these particle trackers. They'll show you where the water is going. And you can, put maps underneath it or terrain, and then use it to bring it to your local decision makers or to kids or to somebody who doesn't really want to talk about a watershed model but wants to know what it looks like and how you can use it for decision making. And just briefly, what we used it for was the wild rice is very culturally important to Ojibwe people, and the reservation is located where it is because we have healthy wild rice lakes there. But we have one wild rice lake named Cedar Lake that hasn't had rice on it since about the 80s. And the reason for that is the lake has become too deep and stayed too deep, and wild rice needs to grow in shallow water. And it's a pretty rural watershed, so no real obvious reason that we could point to why the water was staying so deep. And so we entered a partnership with the Army Corps. They developed a watershed model for us. And like I said, we suspected it was something having to do with either culverts or more rainfall or more runoff or beaver dams or something like that, but we didn't really know until we put together the model and then had the RAS mapper to kind of show that to our decision makers as well. So I'll be in the Wheatley Terrace. I have the RAS mapper up, or at least kind of a video clip of it showing how the animation works. And if you want to come find out why the water was too deep, you can come see me in Wheatley Terrace.
All right. Thank you, Kari. Now, that was a new Nonpoint source record, 9 presentations in 27 minutes. Unbelievable. We do have a few extra minutes. I know some of you are kind of going back and forth, which one do I want to visit first? So we've got a couple of minutes for questions. If anybody wants to ask one of the speakers a question or two before we break and go to our separate demonstration stations. Anybody have any quick questions of any of the speakers to clarify what's going to be in there? Yes. Go ahead, Nicole.
This is just more of a conference question. If we can't, will all the materials or websites or contact information for these presentations be available for those of us that are slow and can't get to all of them?
but I mean, we're going to have available the presentations. I'm just wondering if the materials, the websites, or that type of stuff can be available.
I wanted to ask Adam if he ever offers webinars so that I can become one of those lovers of grits.
I'm sorry, I missed the first part of your question, but I got the laugh. So that's the important part.
I wanted to know if you offer webinars, like when we get back at our office, so that I can become a lover of grits.
Absolutely. Yeah, we'll be recording at least one. That's the hope. And then I am always available for live demos. We can make that happen.
Okay, is everyone clear? Almost all of the presentations are in Wheatley Terrace, except there are two in the foyer in the back. Fred and Craig. Craig from Virginia, Fred from the success story. And then there's one in here, I think. Is that right? Who's in this room? Not anymore. Okay, everybody clear on where to go? We'll tell you where to go. All right. See you at 5:30 on the mezzanine level for the social event.